Let's get it. Chat, what's up? Gotta run that every time. Yo, what's up? Today we got a jam-packed schedule. Let's see. Plasmatic, what's up? How you doing today?
Hello.
What's up? What's up? Round
Yeah.
two.
So Jake already. Oops, sorry.
What were you saying?
I was like, Jake already knows this, but I'm on like 3 hours of sleep right now.
That's crazy. I'm sure you're gonna get this easy, even with 3 hours of sleep.
Hopefully, yeah. Hey, this is like practice for like if I like can't sleep before like an on-site.
Exactly. What happened? There's this loud dog.
Yeah, it was a very loud, very yappy dog. At like, I slept like I was gonna sleep from like 5 to like 1, and then it didn't happen. I woke up like 9.
That's crazy. Yo, chat. Is the audio good? Let me see. I'm gonna tell everyone we got the Code Forces back. Code Forces Grandmaster is back on stream.
Top chat. Yeah.
Nova, what's up, man? Nova, what time did you get home last night? So this guy was out. What's up? Watching from India. What's time in India right now? Current time in NC. What's up? What's up? 12:40 a.m. Okay. All right, we got something for you right before you go to sleep. You get to see a grandmaster go off. Bro, this guy got home at 5. That's crazy. All right.
Well, that's such a vibe though, low key.
Like it was a lit night. That's good.
I don't know.
Okay, I'm gonna tag everyone in the Discord. Be like, Code Forces is back in.
What the fuck actually are hedge funds?
Magnum, I just got done with my Meta phone screen. I need some reviews. How do you think it went? Where are you based, by the way? Also, I'm not gonna lie. I looked closely at my Meta NDA for the interview, and I could barely say anything. They're just like, you can't even talk about the nature of the interview. Da da da. It's like, all right, let's find some good lead code questions. We got a Grandmaster in Code Forces again. I should have prepared, but I know some. I know a couple good ones.
You had I had the stream open, then I realized that you're looking for the questions on the stream.
Yeah. To take off the stream, don't go on the stream. We need you. We can't. What's your thoughts on interviewer coder? Or
interviewer coder?
Yeah.
Have you seen the guy's other startup? It's like so unhinged.
Cluely or something?
Yeah, Cluely, yeah. I saw their promo, it's so unhinged.
Like, as a guy who got good at algorithms, what is your thoughts? Because I think that might be interesting. Because yeah, you're good at it already. People are cheating to get to perform the same level. What are your thoughts on that?
I mean, I think honestly, like at least for me, like it's not that hard to like look the other way because I feel like, I don't know, it's just it doesn't, like if you're already good, it doesn't really affect you. I think I have much stronger beliefs on LLM usage and like actual like competitions where it's like it's been like really bad this year. I think on a lot of platforms, like there's been a lot of LLM usage, and that's like sort of. I don't really know what this means. Honestly, I'm like a little bit afraid that like Code Forces is going to get like
destroyed.
Yeah. I mean, I don't really, like I don't compete anymore, so I don't really like I don't know what the current situation is as far as like people's like beliefs are as far as like how bad the LLM situation is, but like the CCC got like absolutely trashed this year. And there's not that much I don't think there's very much I can say because this is like being live streamed.
Yeah.
But yeah, anyone who's like Canadian and sort of in that like younger age range might have heard of like basically the results were like not released because there was too much like cheating.
I
Um,
see.
and we
That's
couldn't
mess.
go through like all of the cases enough to like be happy with like our results. Was sort of the
Bro, that's actually
conclusion.
annoying. Yeah, like that. I just didn't real. Yeah, people are cheating everywhere. Like, if you're
Yeah.
doing coding competition, why are they even cheating? Well, I guess they want to look good on their coding in code forces so they can get a job, right? So it's like cheating both ways.
I think for Olympiads, it's like useful for uni apps is probably the main reason. Like I'm assuming that's why people cheat on like USACO as well, like for the uni apps, you know,
What's the uni apps?
like university apps, like college apps.
I see. Okay. One sec. Let me find you a good question. What's sort of your strong suit and weak? What area do you think you're the weakest at?
Honestly, probably either greedy or like math, but I don't know if like math is like a common interview test.
Yeah.
Um, Strong suit. I mean, I would probably guess as like graph theory or data structures, but I
I
feel like
see.
data structure problems usually end up being a little bit boring because if you like know most of the tricks, then it's like not. You can kind of just like one shot them
I
pretty
see.
easily.
Okay. Count the. Okay, we're gonna do a. I got a good question. Let me think. Let me just pull up my. Okay, Magnum's talking about his meta interview process. First question done, easy. Second question was 30 plus lines. The interview said, let's end this mid dry run, and left, didn't ask any questions. I have an OA at TikTok in 3 days for a sweet internship. Do you have any advice? I would say for TikTok, just study the basic um, blind 75 questions. I'm pretty sure it's pretty standard. Um,
Mm. Wait, is it for this year or next year? I'm surprised. Both are pretty. Both would be pretty surprising.
But yeah, Plasmatic. Just let me know when they start actually dropping applications for companies because I need to do a PSA to my channel, but I'm not that tuned in.
Like for internships.
Yeah, I want people to know because people start studying for leak code in September. In my head, I feel like if you're
Oh.
gonna, you should start doing it in the summer if you're trying to if you're trying to actually land a job.
Hmm. I mean, I can honestly just give like the stuff that I know from like last year.
Yeah.
Um, I guess
When
because
do
I'm
you
like
start?
still like learning in university. I think like most tech stuff opens up like August, and most trading firms open up in like July or so, at least for internships.
Okay,
The
July.
rough.
That's when trading firms start opening up. July.
Yeah, I think July was what I observed. Like I think around like Jane Street Citadel, like they
Okay.
all open up around the time.
Okay, so people really gotta start studying right now, May and June, like actually grinding leak code. I guess,
I
right?
mean, like the interview process for like trading firms is kind of like weird because like what I've heard a lot of people say like they don't like head count as much. It's like kind of like just rolling applications for the most part until they
Yeah,
close.
like anybody who's good, they're gonna put them on.
Yeah, and it's
Okay.
okay to like apply later if you like feel like you'll be better prepared then. That's what I've heard. Honestly, I kind of um honestly regarding interview coder, like I don't know if you're still pulling up questions. Is it okay if I just yap for a bit or
Yeah,
no?
yap a bit about it. I'm actually curious on your
Sure.
thoughts on interview coder.
Yeah. I mean, I think this is honestly mainly for me like looking around at like the clue like page. I honestly like pretty disagree with like a lot of like what they're basically trying to say, which is like you don't need to think for yourself anymore. Like you can just get AI to like do all of your stuff for you.
Yeah,
Um, I feel like interview coder is kind of on like the cusp where it's like you understand that like a lot of people are very frustrated with the interview process,
mm,
and that it's kind of like feels very esoteric and kind of out of hand for a lot of people. I feel like Cluely, I feel like feels a lot more like this is like where interview coder was going all along, which is like basically to remove thinking from like your life, which I feel like is really bad. Like I don't know, I think people should think for themselves and like have thoughts and like learn things. I don't think you should just rely on AI to like pass everything for you.
yeah.
I just don't think you should do that.
Is that what he's pitching? It's kind of a bit weird, but
Yeah, that's what it looks like. Um, oh god, I keep clicking onto the. Yeah, you're right. I should just close this room.
yeah, close the stream.
I keep like clicking on it by accident. I don't think I've not seen like what questions like any questions yet, but I keep clicking onto it. because like it shows up.
Yeah. I agree with what you said. It's like, wait, I had a good question. I'm trying to figure it out.
Hmm.
Yeah, people need to think for themselves. They need to go through the struggle of getting good at lead code. Or, I mean, what do you think about coding interviews in general?
Hmm. I mean, I think like at least in my opinion, I feel like coding interviews are like indicative of some things. Like I think at the very least, like I think like lead code questions are pretty good at approximating like your ability to like sort of implement like sort of reason through logic, like reason through like a logic you're trying to implement and like actually coding it.
Yeah.
Like the data structure stuff is kind of like secondary to that.
Mm-hmm.
Like the sort of the more mathy reasoning that I feel like may not be as relevant for like
Mm-hmm.
for like most jobs. But like I feel like the core logic stuff is like pretty important.
Yeah.
Like just you can like if you can like implementation fast because that's like honestly a pretty big component of like competitive programming as well. Like every once in a while like at ICPC you'll see there's like an implementation problem where it's like you just have like a really complicated like set of things you have to implement and
Mm-hmm.
it's like the math idea is pretty straightforward but like to actually like render it out into code is like pretty hard.
Yeah. Okay, I got. Did you? Don't be on the stream because I have the questions pulled up.
Yeah, I already closed it.
Sick.
I think at the very least I think if the stream's like delayed by a couple minutes
Yeah.
or not maybe not a couple minutes but at least by like a decent amount of time so um we
So
should be okay. I haven't seen any questions. I guess you just have to take my word for that.
yeah, yeah, you're good.
Yeah.
You're fine. Like in a regular interview, I'm not gonna know what questions you did, so we have to simulate that.
Yeah.
How many leak code questions have you done again?
You mean like total like contest problems or lead code questions
Anything?
specifically?
Yeah. Just
I think lead code questions. I mean that's like mostly for fun, so I don't really like count them usually, but it's like I think like about like 100 or so from just like fucking around.
yeah.
Um, I think in total contest like 2,300 probably
I see. All right.
is sort of
Okay.
the number I've converged to over time.
Let's see. All right. Okay. I'm gonna start this up. I'm gonna drop this as a separate video too, so I'm gonna record. Give me a sec.
Okay.
Chat audio is good, right? Moses, can you say something?
Hi.
Nice, nice, nice. Sick, sick. Okay, I'm gonna send you the lead code question first, but
Sounds good.
I'll do a quick intro. Can I show your code forces thing or no?
I mean you already did, so
Okay, okay. Code forces plasmatic. Everyone go follow plasmatic on code forces. He's also on lead code plasmatic, right? Lead code.
yeah. I think I sent it to you because I was like um maybe you could like find some like
Bro, it's
so I was like check for like any
crazy.
like
3,000 contest rating, only 198 solved.
where's my rating down to? Uh
Took it out this week. Was it a good week yesterday? Or no, you're doing it today, right? Okay.
today? I did like the one like 2 weeks ago. It was kind of cooked. You can see I dropped like 80 rating points from that.
Yeah.
It was
Okay, I'm gonna
kind
start
of
this
cooked.
up.
Yeah.
All right, 3, 2, 1. Hey
All right.
everyone. So today I got my friend Plasmatic again, and Plasmatic is a grandmaster in code forces, and we're gonna simulate a coding interview. He's when do you graduate college again?
Like next year.
Nice. So
Yeah.
July 2026, you're saying?
Yeah, around there. I mean, like it's just like in the like probably April, I think most likely.
Oh, so a full year from now, you have a full year of school left.
Yeah.
Cool.
Like our like winter term ends in April. I mean,
Nice.
technically convocation's in June,
I see.
so technically you don't graduate until June. But like, I mean, there's like a month where you've done your courses.
Nice. All right. So yeah, Plasmatic is preparing for new grad offers. So we're gonna get him right. He's already good at lead code, but we're gonna just keep him sharp over the summer. We might do a few of these, but yeah, he's a grandmaster in code forces. So I wanted to get him on because people really wanted to get him on more and understand his thought process, how he thinks through questions and all that. Yeah, he has a ton of experience, so this is perfect to get him on. He also does lead code contests, so he has a 3,000 rating, which is top 0.01, which is pretty crazy. Guardian level, that's pretty nuts. I don't know is Guardian level. What's the ratings on League Code?
I think Guardian's like 2300 or 2400. I'm not sure. I think that's the last level,
Wow.
from my understanding. Yeah.
All right, sounds good. We're gonna just kick it off. That's a little bit of plasmatic. Let's just get straight into the first question. I'm gonna send you an invite. How you feeling
So
today? I mean, you have a little. You're not running on too much sleep, right?
yeah, this is like the third time. This one's for the video. Yeah, I'm very sleep deprived. I got woken
Okay.
up by a dog this morning. Slept for like 3 hours. It just
I'm gonna send it to you over Discord.
sounds good. Oh, wait, I've like seen this question before.
Oh, you
Like
seen
I've
this
like
question?
I haven't like solved it, but I've like seen this question before.
Do you know how to solve it optimally?
Uh, I don't know. We'll have to like actually do the question for me to remember whether I've done this question before, like or not
Okay, let's
properly.
run. Let's just run.
Wait, I can
Let's
check
just.
submissions. Okay, no, I haven't submitted to it.
Oh, you
Okay,
tried
so
it?
like no, I have not submitted to it. So
Okay.
like, I've seen this. I've seen this question before, but I've never like coded it up.
Okay. Let's see your thought process then. If we get through multiple, then it's all good.
Okay. So this is insert, remove, get random. Um, is there so we want the functions that each function works in like O1 average time complexity. Hmm. Oh, like thinking about this. I feel like oh, I see. I think I had some like idea at some point that was kind of silly. Let me think. Okay, I think this because this is like especially because this is average, like I think that already kind of takes you towards like this is probably like amortized or like random of some sort. Um, at least my thought here is like, so for insert, like you just kind of push like basically all of the elements into like a vector, like as you insert them, and then for remove, you just sort of mark each element as like deleted, basically. Like you would mark the element as deleted. So then you don't have to like do like the actual like vector erase, which is like linear time for the remove. And then you implement get random by just like basically querying random indices in the vector, and then you query again if it's like removed already.
Mhm.
So I think that should get you like constant time for all of them, except if too many elements are removed. Then the get random ends up, I think, could start taking like a long runtime because you're basically like jumping around constantly to try to find like an element that still exists in the array. So when you could say when the array reaches like a certain number of like dead elements or like elements that have been removed but haven't been like actually like physically removed from memory, you just like basically rebuild the array. So you just keep only the ones that are in the vector in the moment.
Okay.
Yeah.
So you're gonna have array under the hood, or what's the underlying data structure of this?
Yeah, underlying would be like an array, yeah. Or like a vector, like a
Okay.
C++ kind of vector, yeah.
So inserting, could you walk me through the different functions here?
Sure, yeah. I think we could probably do we could honestly do like just the sample explanation. So you're on the leak code, right? Like
Yeah, but
the
I can see here.
all right, sounds good. So I'll just like look at the operation list here. So we have basically this is the set of operations. Why is it still looking? Okay. So we have like our array, and then like it starts out as empty.
Yeah.
And then so when we insert, we just like add it to the array. So for insert one, we just add one to the array. And for removals, what we do is we mark it as deleted. So in this case, remove two would do nothing because two is not in the array. And I know there's like how do you find the element in the array? I think you could just use a hash map for that. So I'll omit the hash map for now because that's like the easy part of the problem. And I think it simplifies the explanation a little bit. So just assume we have some way of like knowing, of finding the index of like any like element in the array.
Okay.
So I think okay, yeah. So for remove two, we just do nothing. For insert two, we just add a two into the array. So now we do get random. We just query like a random index. So we just query like one or two. to say we can like get random or return 2, for example, in this case. And now when we're removing 1, so what we do here is we just mark the 1 as deleted. So I'll do that with an asterisk.
Sure.
But in like actual code, you probably just use like a second array or like a struct instead of individual integers.
Okay.
And then for insert 2, we see that 2 is already in the set, so we don't add another element. And then when we do get random, basically the bad case is if our random index falls on index 0. If we fall on index 0 and we see that the element's already been deleted, then we just retry.
Okay.
So in this case, we're basically just going to retry until we hit 2, which should be like constant number of calls.
Yeah, but you said if we have a lot of deleted, it's very sparse. What if we have a very sparse, like the real values are sparse there?
Yeah. So if values are very sparse, then you have to occasionally rebuild the array. So this is kind of like a little bit. Actually, maybe this is a little bit too like math like proofy, but so sparsity would be like at least my thought is like if the array is more like half deleted elements. So in this case, we'd hit that threshold if both elements were deleted, because that's more than half. Then what we do is we just basically go loop through all of the elements and then just create a new array, loop through all the elements, and then only add the ones that are like actually like in the array. So then what that does is that sort of gets us back to like the original state. And the idea there is that you have to make a linear number of operations until you get to a point where you need to rebuild. So the total like sum of like rebuild sizes is going to be like basically proportional to the number of operations you do. Like you only rebuild every so often.
I'll say one thing. It says average O1, but it's a bit misleading in that question. We could probably get in it like actually O1, because yours is average O1.
Like actual
constant everything.
Yeah. I mean, this is like a bit cheeky. I think technically, even if you don't rebuild, it is like technically O of 1 complexity, but I don't think that's what you want.
Yeah, no, I want something else because, right now, what's causing the bottleneck in here, right? What's your insert runtime and remove runtime?
I mean, insert and remove are both constant time.
Okay.
So there's like a backing hash table that just maps all of the elements to like the indices.
Yeah.
So the insert and delete will both touch that.
Yeah. Okay. And then what's get random gonna like? Is that the one that's might not be over one?
Yeah, get random is the one. Or honestly, I think it's probably gonna be remove generally, because the idea is like remove is going to mark more elements. So if a removal goes past the threshold, then you like rebuild the array. The idea is that like at most like half the elements should ever be like deleted from the array. Mm-hmm. So on average, get random should only require 2 tries.
I see. Okay.
Or something like that. It's like 2 tries.
Is there a way to have remove actually, or get random to just be O1, not average at all?
Like probably this might be like one of those like really weird tricks that I don't know, I don't remember. Yeah, like we want them to all be like constant.
Let me walk through an example quickly. We insert 1, we insert 2, then so we have an array of 1 to 2. And then can you show me what the hash map looks like? Because I think it's important that as well, because that's a key part of this question that you mentioned.
Yeah, that's what I was thinking, because the hash map is the only data structure that lets us like sort of arbitrarily insert and remove elements in constant time.
Yeah.
So for insert, what we basically do here is that the hash map maps the value to the index. So it would map 1 to 0 and it would map 2 to 1.
Yeah.
And at least in the current sort of implementation, it's mainly just used for removals to like figure out which element we're trying to delete. Insert kind of just adds it to the end of the array.
Okay. Let's insert 3 right here.
Yeah. So for insert 3, we would just push 3 to the end, and then the 2. This becomes like 3 to 2.
Okay. This is like okay. What happens when we remove?
So we remove 2. We query the hash table here, so we see there's like 2 that like element 2 maps to 1.
Yeah.
So we mark 2 as deleted. And then we also remove 2 from the hash map.
Okay, but then it leaves it in there, which is causing our runtime to be bad and get random, right? How can we get it out of there? It's
Like, are
kind
you
of weird.
asking for like average O of one, or you said you wanted worst case constant time, right?
Yeah, I don't want average O one. I want basically I want you to remove two there,
Yeah.
right? Because if we just let it grow, like I understand your theory of like pruning it from time to time, but
Yeah.
there's a way we can kind of prune it, right? Like as it
Mm.
happens.
I mean, you could have like a linked list instead. But like the thing is that like you can't randomly index a random access like a linked list though, which is the
Yeah,
problem.
that's the problem. Yeah.
Yeah. Maybe there's some like other kind of data structure that we could use to like sort of index into the array. Um, yeah, I've actually thought about like what the unamortized solution to this is. I mean, there are like ways to like de-amortize this, but like I think that's like kind of like I'm kind of like I feel like I'm like hitting things like with a hammer at that point. Like it's not really like a nice solution that's like easy to convey per se.
Yeah. This one
Yeah.
is like a slight little trick
Yeah.
to get it out of there. So what's the problem if we just straight remove two? What happens?
If we start remove two, the issue is we have to shift all the elements back
Okay.
basically.
It's like
So
what operation on an array actually gets us O of one removal?
I mean usually pop back would get you like O1 removal.
Yeah.
Oh, you swap it to the back and then you pop it.
Yeah.
Like
Let's see.
like yeah. Um I guess you'd have to update the hash map as well, but that's fine.
Hmm.
Right. So I guess that seems like the solution then in that
And
case.
then okay.
Oops, oh shit,
Can we,
no, okay, I didn't mean to do that. My bad, my bad.
okay, let's walk through it then. Okay, we have two, three, right? And I remove
Yeah.
one. What would we
Yeah,
do?
so for
Like
yeah,
walk
let's
me
go back
through
to
how
this.
the hash map in arrays is gonna change.
Yeah. So the idea here is that pop back is constant time. So we first swap 3 and 1, since 3 is the last element. So then we also have to update the indices in the hash map. Um, and then we just delete the 1. I guess we don't need to update the index for 1, but well, you get the idea. We have to update the indices to sort of correspond to the actual elements in the hash table. And then, sorry, the actual indices in the array, but then we just swap the two elements and then we pop the last one.
Mm. Okay, cool. Yeah, go ahead and implement. Then what would be your
Yeah.
runtimes now from all of them?
I think they should all be like pretty straightforward, like constant time. I guess. Do you want to just walk through that while we're coding? Because I feel like
Yeah,
it'd
yeah.
be more cool if we just
Write
code.
it out and then we'll talk about that at the end.
Yeah. So I guess the array would be that. Uh, so we have a dictionary and we have an array. So for the array, we just push. So we would say self.array.value and then equal to. So we just need the last index because we know we're pushing it to the end. And then for remove, we'd like to swap basically the last element and the element that we want to remove. So to remove is going to be equal to the value that we want to remove. And then we'll say swap. So this is going to be like a little bit, like I'm not sure how exactly I want to sort of implement this. Like what's the cleanest way? I think I'll just try like some way of implementing it basically. And then self.array one is equal to. So this is just swapping elements in Python
Nice.
format of it. And then we want to update the index of the last element, which is now in to remove index. And we also want to delete the element we want to remove. So, and then we finally just pop the array, last element. So wait, so this is without the bool checks. I guess I have to do the bool checks first as well. So this is just in the true case. These are both in the true case where we like assume like the programmer is not doing something like bad. So val in indexes, let's return false. Then we paste it here. True. And then over here, forget random. We can just query random index. So I'll probably just do. I don't really know how to. Honestly, kind of forget how to do this.
Brand int or something.
Yeah, I think it's like random.c. Just to say like, what's today's date? I just do so 2020, April 26th, and then.
Yeah, I'm gonna give you the code.
Oh yeah. Oh, I see. I see. Oh, thanks. Yeah, I was just seeing it with.
These are
Alex.
inclusive. Inclusive. Both 3 and 9 are included in that code.
Yeah, sounds good. So I guess this rand index is equal to random dot randomness 0 dot. I guess if you were doing this in production, you probably want like a random number generator that's attached to the object itself, just to make it a little bit more isolated. But that's okay. We don't need that today. Yeah, I think this should be it. I think I kind of just like blitzed it. So
okay, walk me through line by line.
Sure.
Quick.
Okay.
From the insert.
So for insert, we first have a check to make sure like the element's not already in the array. And then so what we do is we just add the new value to the end of the like our vector, and then we just update the hash map. So we know the hash map is we know the index of the value is just the last element, so we just length -1. Then we return.
Okay.
So for remove, it's a bit more complicated. We have the if check at the very beginning as well. But in this case, we first query the hash map for basically which index we want to remove. Then in the next 2 lines after that, we swap the index we want to remove with the last element of the array. Then we update the index, the hash map for last element. So since we did this after the swap, then we just basically say the index of to remove index.
I see.
And then finally we delete we delete the value we're going to delete from the hash map, and then finally we pop the last element of the array. So we can think of it as sort of 2 phases.
I see. Okay. And then random, what are you doing there?
Since the array just contains all the elements, it's like a set of all the elements that we have, then we can just query a random index and return it, basically.
Cool. All right. Submit and run.
Hold on 1 second. I'm getting a call. I'm just gonna message them.
Oops. Looks like it's
busy right now. I'm in a meeting. How can I call you back later? Mom's calling me. It was kind of scuffed. So mom's calling me about some stuff. Is it fine if I mute for a second? I'm not sure what she's asking for.
Yeah, go ahead. I'll pause for a sec. Yo, chat. This is a Grandmaster in Code Forces, so I don't know. I can't. Yo, X, thank you. So, yeah, this is a Grandmaster in Code Forces, so he might body that question. But I'll ask him it anyways. I got you, Golded, I got you. And we'll do 3 questions. Well, Alpha, I almost got him with this question, right?
Yeah, it was a pretty short call, but yeah, I was just asking something.
Cool. Okay, I'm gonna start this up again. All right,
It
looks like you got something wrong.
Yeah, I'm looking at it now. It says so I got true, false. So what is it? So I removed 2. Think. Oh wait, I put return true instead of return false in the guards. For some reason, I think that might be the issue. Yeah, I think I just you see the statement that I'm highlighting. It said return true. Oh, it's wrong answer.
Okay.
It doesn't say for me what I got wrong. I'll just try submitting it as well because I can't see it when you submit it. Oh, I see. It is returning. Wait, what? Why is it? Oh, I think it's because of the rand in at the start. Maybe. I'm not really sure. Is this saying that I'm removing an element that doesn't exist, or am I a little bit what? So we remove 1, insert 2. So we insert 0, insert 1, remove 0, So, oh, I see. So it has to return 2. Let me see here. Why is this giving me the wrong answer? Is there a way to just copy the test case
Returns a
into it?
random element. Yeah, I already copied the. Yeah,
Yeah.
yeah, you can
It
copy
only
that.
has yeah. It only 2 is I looked at the case that I got wrong, which is test 5. I think it's only the only element in the array is 2 at the moment. So the fact that there's 1 there is kind of bad.
Okay, how would you debug it?
I think probably what I would do first is just print the array after every operation. So I would print like self.array. I think that should get us like far enough to being able to figure it out. So this is after every successful operation. So I'm looking at the output right now and seeing what the issue is. Are there any operations that so all the operations are successful? So that's a little bit easier for us to debug. So it's 0, 1, remove 0. So it is removing the it's removing the 2 for some reason instead of the 1. That's interesting. So it's removing it should be removing the 1, but it's actually removing the 2 for some reason.
Hmm.
Because after the insert of 2, the array becomes 1, 2, and then after the removal of 1, it becomes just the element 1 when it should be the other way around. I wonder if the swap is not working, like maybe like the swap is not working as intended. That is my guess. Because it doesn't look like the elements are being swapped at all.
Hmm. Okay, how do you debug it?
That or the dictionary is wrong. I think just for like the next one, I'll comment out the swap and um I'll just have it assign it to like a temporary variable. So it's like temp is equal to like uh I'll just use like a temporary variable for now just to see if because I know like like this tuple syntax might be a little bit strange. Like maybe it'll cause some like unintended behaviors. So temp is equal to remove, so is equal to like wonder if that just clears up the issue. Um okay, no, it's still causing the same problem, so I don't think that's the problem then. I guess maybe it's related to the indices themselves might be the problem. Not sure. Let's print the indices as well. So because that sounds like the indices sounds like what's the issue? What the issue might be caused by. So like sorry, by indices I mean like the
Yeah.
dictionary. Oh, I wasn't sure if I should use indices or indexes, and I wrote indices and I got a type error. Oops. Yeah. Yeah, looks like that's the issue probably. Yeah. Oh, I see. It's saying both element like the 1 and 2 both point to the same both index 1. That does not seem right. So after these first 2 inserts, the dictionary is correct. After the removal, it seems like um the index is now wrong. So why is that? So in this case, we're removing the index 0. So we should be swapping 1 and 0 and then popping the element. Um that's really strange. See. Oh, I see. Wait, no, it should be oh, I'm indexing into indexes using using itself. I should using an index. I should be using the array elements. I think the issue is here at line 29. I think I'm not indexing into it correctly. Yeah. Oh, I see. It says you submitted the code. Wait,
It
what?
says output
Oh,
limit. Okay.
too much, yeah. You just actually, yeah, you're right. We should probably keep it in case of wrong answers. Yeah, there we go.
All
Okay, yeah,
right.
passes.
Looks
Nice.
good. Cool. All right, we're gonna move on to the next question. Could you leave this one?
Sure,
Just
yeah.
to end. Yeah.
Oh, I see. Got it. All right.
Do they want to ask? They want me to ask you the softball question. It's a pretty good question. I think it's they ask it in a lot of interviews, so I'm gonna quickly ask it to you. Um,
Like softball is an as in like an easy question or like a question about softball.
no, it might be too easy for you. We'll see. Oh shoot, shoot.
All right.
Let's see. What's everyone saying? Okay. I'm gonna send you an invite.
Sounds good. Mm,
I'm gonna send it for you on Discord.
yeah, I'm just watching Discord right now.
Are
So
you?
VFA. Oh, I
If
guess it's not about softball. So I guess I'll just read this question
yeah,
first.
take a read.
Uh, so we have M by N grid, either an empty cell or a rotten cell or fresh. And then no cell has a fresh orange. Wait, isn't this just BFS?
Yeah. So what are you thinking?
Um, so the time, so we just consider like if we could compute like the basically the rotting time for like all of the oranges, or like what is like the last, we could basically like simulate this with like a breadth first search. Because like I think like the way I'm thinking about it is like you can also think about it in terms of like I don't know if anyone's heard of the term like flood fill.
Hmm.
It's like using like breadth first search to like simulate like water flowing across a maze.
Yeah.
And I feel like rotting oranges is kind of like a similar idea.
Okay.
Like it's like the same kind of like if you just
So
picture it in your head.
I mean, could you write down some notes and walk me through like your thoughts here on how you're gonna solve it? Just you mentioned
Um,
BFS, but yeah, like
yeah,
what node do you start on? How do you figure out the number of minutes that it took, etc.
right. Hold on, I'm not. Wait, was my why is my I can't type on this for some reason. Hold on. Oh, my keyboard's broken. Wait, hold on. This is kind of bad. I think my keyboard's broken. Like, not my keyboard is broken, but my browser's not accepting any keystrokes.
Maybe
Let me just
refresh.
reload it.
Yeah, refresh.
Yeah, I'm just gonna refresh. So I might like boop out of the meeting for a second.
Yeah.
Still is. I might need to just. Okay. Still can't do anything. I might need to like restart my browser. 1 second.
Yeah, restart. Restart.
Yeah.
So the oh okay. Wait, gotta pause for a sec. He's but we'll get him back on in a sec.
Let me. Oh, I'm in the meeting. Never mind. Let me see. Okay, yeah, I can type now. I can type now. We're good, I
Okay,
think.
six.
All right.
Okay.
So I guess like, how do we want to do this? We could probably use like dots to represent nothing, and then we can do like a small O and like a small X and like a big X for like fresh and rotten oranges. So we can do basically minute zero. It's just this. So this is what minute zero looks like. Um, and so basically, this is what the grid looks like. So for our graph, oh wait, my video's on. Why is it on? For our graph, the nodes are basically the individual like grid cells.
Mm-hmm.
The starting node is going to be all of the rotten oranges at the same time. So we push all of them into the queue. They all have distance zero at the beginning.
All the
So,
current rotted ones.
yeah, all the ones that are rotted at the start.
Okay,
So like our start node, we have like multiple start nodes in this case.
sure.
And then we can define adjacency basically in terms of like, wait, what is this? Wait, why is this -1? Oh, I see. Ron only has okay, never mind. This is fine. This is a separate input. Um, and then so the way we define adjacency is just like in the problem. Basically, we go either like up, down, left, or right, like one of the 4 directions.
Mm-hmm. And then
Yeah. And then so now we have all the distances to all of the oranges. Basically, the distance to like any like grid cell represents how long it'll take for that cell to rot. And then so we just take the maximum out of all of them. And then if there's any that have like a distance of like infinity, then we know the answer is like
okay.
basically
All
impossible.
right, cool. Sounds good. All right, go ahead and implement.
Sounds good. So would you DQ first? And then we probably say like just dist is equal to, let's use n and m for this. So n is equal to 1 grid, m is equal to 1 grid 0. And then this is like an m by m grid of, I just use -1 usually. So we do -1 or n. And then I usually call the BFSQ as Q,
Sure.
which is maybe like a little bit terse, but that's okay. So now we find all the initial rotting oranges. If grid ij is equal to, a rotting orange is 2. So we do 2, and then we will say q dot append ij, and dist ij is equal to 0. So then we do, while the queue is not empty, our current cell is equal to q dot pop. I think pop left. Yeah, pop left. And then we need to go for the adjacents. So for the adjacency, we'll have like probably like have like a function of some sort. For any like individual cell. And so an adjacent cell is valid if it's within the bounds and also is not empty. So it's like some kind of orange,
Sure.
basically. I think it's okay for like say like rotting oranges to pass over other rotting oranges. I think that's like okay. It shouldn't really affect our problem at all. So for posin, so for HJC in so R minus 1C, R plus 1C, RC minus 1, RC plus 1. And then we'll say like, so if and if this is true, and also grid is not equal to an empty cell, then we do and return adjacents. So that's our get adjacents function.
Sure.
And then so we do, we're just gonna, this just makes it a little bit easier for us.
Yeah.
Like this is abstracts a
That
little
makes
bit,
sense. Yeah.
what I like. Just get our adjacents. And then if, is it dist or dist? Dist, okay. Equals to -1. Sorry, equal to -1. Then we do get the pair here. And then we equal to dist RC plus 1. That should be our BFS in total. And then now all we have to do is basically check what the maximum out of all the distances are. So I think in this case, this like max time is equal to, let's say just
Okay.
0 for now. And we'll just break early if
So we're using up extra space here, right? Is there a way we can use up no extra space?
no extra space for this.
Yeah. Space optimized.
I mean, you probably can, yeah. I think we could like get, actually, we could probably just use like the grid itself for like the distance if you want. Would you prefer that instead?
Yeah. Let's space optimize this.
Sure, I mean, we can do that.
Mm-hmm.
So yeah, I think in this case we'd probably just use we would probably use like the grid itself instead as sort of like the distance array. Um, sorry, as like basically like basically the visited array for our graph traversal. And then I think since for BFS you don't strictly need to like know all of the distances that you're computing if you just want to compute some like basically some like aggregate value out of all of them. I think you can just store the distances in the queue itself. So what that looks like is we delete our distance array basically, and then in the queue we just append the distance as part of the queue element. So in this case we have RC and then we have dist. So we say if grid adjacent R adjacent C is equal to 1, then we just append dist plus 1. And we also update our grid as well. So in this case, it's equal to 2. So I think the other thing we want to do here is we probably, since we only care about adjacencies that are like oranges, we can update this to be a little like maybe look a little bit better organized. So I think here what we want to do is we can instead just collect our maximum distance like while we're doing the BFS. So we say max dist is equal to 0, and then we just collect it here. And then the final thing we have to do is we just have to check basically if we found any like oranges that are still not like rotten. So if grid ij is equal to 1, then we return -1, else we return max dist. And this should be it. I think passes samples. Oh, nice.
Nice. Okay.
So then, yeah.
Okay. Cool. Wait, walk me through line by line the code again.
Sure, yeah.
To see if there's any
So
optimizations we can make. I'm
yeah,
being really
so
hard on you because you're grandmaster. We gotta get it fully optimized.
I mean, honestly, actually, interestingly enough, like I feel like a lot of these like optimizations, like stuff like going from like 2 arrays to 1 is like pretty rare in like competitive programming.
Mm-hmm.
Like
I see.
At least for like algorithms, like you tend to stick to like specific patterns. So for example, if I do BFS, I always declare an array named dist
I see. I
that is
see.
like the size of the graph.
Okay, this is more
Uh,
like a lead code interview kind of
yeah,
thing where they try to make you. Okay. All
yeah,
right. Actually, let's just go on to the last question.
sure,
We
sounds
still have
good.
25 minutes left. That's why. Because the video has only been 35 minutes so far. Okay. Would you be able to exit? Click end.
Yeah, how do I?
End.
You
Just
said
end.
end,
At
right?
the top right. End. Maybe
Oh,
that's why I didn't kick you. You couldn't do the last one.
oh, I see. It says leave. Yeah. All right, there we go. I left the collaboration. Does it say that it's submitted to the problem? No, it doesn't. That's weird.
All right.
Oh, this is because it's like technically not my code because it's collab.
All right.
Yeah.
Let me
Didn't
get
know they
you
had
some.
rooms. It's pretty nice.
Yeah, it's really clutch. Wait, just seeing the elo on this question.
Wait, don't tell me.
Weekly. What's the current weekly contest right now? We're already
Uh,
447.
yeah. I mean, there was like a bi-weekly this morning, so you could probably use like a problem from that maybe.
Yeah,
Or I don't.
I kind of want to know how to answer the question so I can give proper
Oh,
hints if needed.
SSD. Yeah, I think the one
Okay,
today is.
I'm gonna send you this question.
Yeah. The first one was kind of interesting. It reminds me of like the way you implement deletion in heaps.
Hmm.
Because you like I think it's like you like I don't like remember 100%. It's like I think you like swap the element to the back and then you pop it off. For what I remember, for like a like just like binary heap. So if I
Yeah,
just
like a
go to,
binary heap, you swap the top with the one at the very end too, right? Like if you implement
yeah,
the binary heap using a array.
yeah. Damn, you're making me work for this. I told you I was bad at math and you gave me a combo problem.
This is not too much math.
Oh, I see. Okay. I just thought it was kind of funny. I don't know if you prepared like these ahead of time given my answers.
I just done this question before, that's why.
I see. Yeah. So a dice, I just saw it was combo because I saw it said modulo 10 to the 9 plus 7. And I was like, okay. Dice simulator generates a random number for each roll. You should just constrain that it cannot roll the number I more than some number of consecutive times. Given an array of integers on a roll max, given the number of distinct sequences that can be returned with n exact rolls, and you obviously, of course, modulo it by 10 to the 9 plus 7. So roll max is almost 15, and the roll max length is always equal to 6. N is the length of like the number of rolls you do in total. So I think I have to like probably think about like a couple of different ways to approach this problem first before I think I say anything.
Sure.
For anyone that was like watching the last video, there was also a combo problem, but I kind of just started jumping into it immediately,
Hmm.
and I feel like that kind of ended up going in circles a little bit before I ended up on the final solution. So I feel like here maybe it'd be better to like think through more of the problem before answering. Um, so we have 36. Yeah, so we have these like these are these like limits on consecutive rolls. Okay. So since n is quite small, I feel like you could probably wait. I think you could just DP this actually, because n is quite small. And you only need to know the last element that you hit, like the last element, the last like value that you rolled, and the number of times you've hit it. And a roll max is only 15, so you can have conceivably just chuck a couple dimensions onto the DP and then it'll work. So I'm pretty confident. I think a DP would work for this problem.
Okay, so could you write down some of those notes because I think it's important. You made a few assumptions there, right? You're like, we only need to know the last one. We could use DP because n is small, etc.
Yeah. So, oh, sorry, not n is small because roll max is small. That was what I was thinking. Yeah. So the DP state would be the number of rolls, the last die value. So this would be 0 for the first like for the 0th roll since we haven't rolled anything yet.
Hmm.
So this would be like let's call it like 0 to 6. And then the final dimension would be number of consecutive rolls. Something like this would be it, basically.
Okay, go ahead and implement that then. I think your solution makes sense to me.
Yeah, I think with DP, like a bit more meta commentary. I think DP is like a little bit easier to honestly, I feel like it's a little bit easier to like I guess explain and honestly do compared to other problem categories because I feel like the explanations tend to be more straightforward. Like they follow a more systematic format versus I
Mm-hmm.
feel like other problem types like greedy and I think especially like the first question that we had like the get random it felt like it was kind of like the it feels like a more long-winded explanation. You have to like kind of be more creative. TP, I feel like you kind of just state the state the transition, and you code it up, and it just kind of works.
Mm-hmm. Okay.
Yeah, that's just
Mm-hmm.
my personal thoughts on this. So for range, we'll go up to 7, so we can have 0 to 6 of the values, and then we'll do for in range n plus 1. So TP of 0, 0, 0 is in this case. And we'll say the modulo is 10 to the 9 plus 7, so we have that. Um, so we're gonna go loop up to n, and for j in range, I think j in range 1 to honestly just j in range 7 like that, and then for k in range, the roll max is 15, so ideally we wouldn't like loop up to constant values like this in like real code, but welcome to competitive programming.
Mm-hmm.
Um, but so yeah, so in this case we just pick the next roll to learn. So next roll is basically gonna be either 1 to 7. And then if next roll is not equal to j. And it's like, I think there's the other condition, which is a bit more complicated, is like we like the number of consecutive rolls. So it's something like, I think it's like next, oh, roll max is a 0 indexed array as well. So we have to be careful about that. Next roll is equal to j. If, so I think it's like, I think I'll just have like a negative condition first. Like the specific condition is like, yeah, so next roll is, if next roll is equal to j and the so roll max of next roll minus 1, k plus 1, k is equal to that. Actually, wait. I think I realized. I think this is okay. I think we can have 15 for this actually. So there's a bit of like, there's a bit of trickery here. I think we need to have it be like this sort of this be the minimum solution. I think it's still okay to have like a DB state that's number of consecutive rolls because the number of consecutive rolls can be up to n, right? Because you can have like 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and that's like a. Oh wait, no, it's limited to 15. What am I saying? Sorry. This is okay. My bad. So next roll is equal to j. So we have next roll equal to j. Then if next roll is oh sorry, yeah, if next roll is not equal to j, otherwise these two cases here, then this is going to be dp of I plus 1, next roll, and it's just going to be one roll is as equal to dp of ijk, and then we mod it. Otherwise, we do something else. So if k is less than roll max, next roll minus 1, then we can update it. So the next roll is going to be the same. It's going to be k plus 1. Otherwise, we can't choose the same thing. So I think this is probably what I want. I think this is sort of it. And then we'll just sum up the total. So we just consider all dice rolls and all possible roll max values. So for I in range 7 or j in range 15, I guess roll max is up to 15. So we probably want to update 15 to 16. There we go. BP of n j. And so the nice thing about Python is we don't have to like strictly always be under the integer limit. We can go a little bit over if we want to. So we got accepted on the sample. So I just submit.
I'm
It's not a small.
submitting. Oh wow, that was quick. How long was that? Chat, how long was that? That was crazy. That question took me like 40 minutes when I did it.
Mm,
I did it top down though.
Yeah, I
Okay,
think
just walk me through your code real quick, and then
yeah. So I think so this is like sort of expanding the meta commentary I had earlier, which was like you just state the state, you state the transition, and you're done. I guess in this year it's probably most productive to just state the state and transition. So state is just a comment you see below here, which is like this. Remember that
the
it's
number
number
of
of
rolls.
rolls,
Okay.
and then the last die value. In this case, 0 represents like you haven't made a roll yet, so you can pick any value, and then the number of consecutive rolls that you've made with the same value. So first we initialize the DP array. We initialize our like initial state, which is just we haven't made any rolls yet, so that's what that state looks like. It's 0, 0, 0. And then we loop over all of the values sort of in order, all the states in order. Um, in this case, like we know we're filling out the DP table in the correct order because we're always going up in the first dimension, so the I loop itself is sufficient to guarantee that we're looping in the correct order. Um, and then so what we do is we look at every single state that we're in, and then we look at what possible next states we can go to. So in this case, it's going to be based on what the next value of a dice roll is. So that's going to be any value between 1 and 7 exclusive, so from 1 to 6. If the next roll is not equal to our previous roll, then the number of consecutive rolls resets back to 1. So that's where we update here. Otherwise, if it's the same, then we have to make sure we haven't hit the limit. So we need to make sure that k is less than roll max of next roll.
Okay.
And if that's okay, then we can just basically update the DP array for the next state, and then we just include a bunch of mods everywhere to make sure like our code is like correct. Like
Yeah.
doesn't go too far over. This is like a small specific about Python specifically. So Python has big integers, and so you don't technically need to mod except at the very end. But I think Python will sort of silently like switch out your underlying data type into big integer if you don't mod it. So for example, like if we commented out all the modulos except for the last one, our code might actually TLE. Do you want to try that out? Kind of curious.
Sure.
I'm not sure if that would actually happen, but it'd be kind of funny if it did. I think our code is fast enough that it probably is not an issue. So okay, so it's still passed. But for like do you have the runtimes for both versions? Because
Yeah, but
this one
sometimes
is.
it tweaks like the leak code.
Oh, that's true.
Yeah, like it's not. Yeah,
Yeah.
that all makes sense. Okay, how do you think you did on the three questions?
I think the first one it took me quite a while to get to the answer. I feel like this one was very like bimodal kind of answer wise. So it was like either I like insta solve the question or like we sort of like sat there for a while and like really thought about it. I like the first problem because I thought the trick was pretty clever.
Mm-hmm.
I'm sort of using like the heap borrowing like the binary heap like deletion strategy. Um, but maybe if I was more awake and not on 3 hours of sleep,
Yeah.
I would have like sort of came up with that without any hints. But
Yeah.
I'm not sure. Like I actually have a question for you since
Sure.
like you're a senior software engineer and probably have done interviews.
Yeah.
Would you consider like the hints that you gave for the first question as like too much? Because like I know like sometimes interviewers will give hints because they just want to keep the questions moving and not because like they feel like the candidate like actually like should get those hints or not.
Yeah.
Like
Let me see.
yeah.
I would say it depends on the level, right? So I
Hmm.
mean, most roles you in the criteria it says solve the question optimally with minimal hints or with a lot of hints or with no hints. I think it's
Hmm.
kind of unreasonable to just fail someone for giving like one or two hints, right? Especially
Cool.
when if we dissect where you got there. Okay, you had the hash map, you had the array, you figured out a
Mhm.
solution to remove it, right? But the one thing is
Right.
you're gravestoning it or tombstoning it,
Yeah.
but not actually deleting it, and that was causing it. So my hint was very specific. If I had to give you a hint to use a hash map, then I might fail you or something like that. Like I just gave you the hint of um I want it O of one. So what's an operation on an array that's O of one, and then after that you oh yeah, just push it to the backhand. Like you figured it out kind of thing. But I think what I would consider the help I gave you is minimal help. So I wouldn't I think I would still pass you there. Definitely pass you. If someone did the whole question with no hints, then it's like a hard yes, like a strong yes. I think for the first question that's just a yes. But that's why there's multiple parts to the question. Like if you do okay on one part, you're just getting warmed up, right? Second question you did easy. Third question you destroyed it. That's a hard question. So I think overall you're still a strong yes. I think that hint that I
Mm.
gave you was still minimal because you
Mm.
understood every part of the question except for how to remove them, right?
Mm. Right, right.
So
Mm. I
yeah,
see, I see. I guess for like data structure questions, it's a bit easier to like sort of break it into separate parts. So it's like you can kind of solve like 70 or 80% of the question. Um,
yeah.
and like
Okay,
that's possible.
yeah. I wrote some notes though that I would say because yeah, I've done a ton of interviews. I would say let's see for question one. Yeah, I think you mentioned a lot of things, but like jotting it down quickly would help as well. So I understand what you're saying.
Hmm.
Even you see when we worked on question one, you're writing out what the hash map and maps look like. I think
Hmm.
that helps the interviewer visualize it, but that's just like in my case because sometimes I think you go into jump doing the question right away, or you say a bunch of things. It sounds right, right? Like mostly it's the right direction, but even for the first question, you said 90% of it. But I knew that with the removal there was an optimization, so I wouldn't have been able to give you the hint unless we like wrote it out like that.
Mm.
So I'll just say write down some of your thoughts a little bit, right?
Mm. Which
Um,
I think, because one thing I've noticed is that I feel like I tend to sort of, I mean, obviously writing would sort of slow me down, so I'd like to be able to like make as many ideas as possible to start. Would
mhm.
you say that like the list that I make should be like more refined, as in like these are like ideas that I think are good, versus just these are ideas? Because I feel like sometimes I've noticed in previous interviews where, or just even just like talking to coworkers and stuff, it's like I have a like a direction and a problem where like as I'm saying it, I realize that it's incorrect, and then so I tend to like backtrack, and I
Mhm.
notice it tends to confuse them.
Yeah, I would say it's because you go through like three or four ideas, and then
Mhm.
none of it is written down. So I'm trying to take notes as fast as I can too of what you're saying. But as like an engineer, you should be able to show that you could like take notes and talk and write down your ideas. I think. Um,
Right, right.
like if you when you watch over the tape, just because you explain the solution, but none of it is written down. So I feel like it'll help convey your thoughts better if you write some of the things down. For example, one thing
Mhm.
is you talked about a hash map, but you said it wasn't that important for the first question. But I think the hash
Mhm.
map is like one of the most important parts of this question because it
Mhm.
makes everything O of one if you have the hash map. And then how are we how are we updating the indices? So I think the main thing is because the question is too easy for you, you don't think that it's worth talking about. But I think if you're maybe for hedge funds and stuff, it might not be worth talking about, but for fan companies,
Mhm.
even unicorn companies and stuff that I've interviewed at,
Mhm.
though they want to know that you thought about those. Like for that first
Right,
question, right? The hash map is the most important part. Well, and also the array is important, right, for getting the get random. But then how are we
right.
moving the indexes and stuff? But yeah, that would be kind of my advice. I think obviously your coding is really good, but I think conveying the thought process is just something that we could like figure out a better way to do.
Hmm. I see. Yeah.
But I think I still think you did really good. That's the main thing I'm hitting on. Like, what do you think about that feedback of the?
Yeah. I think it's pretty interesting because like I haven't really honestly I've like never actually sourced feedback before from my
Mm,
interviews. I think it's partly because like they're kind of like confidential to some extent, I think.
mm,
I've kind of always just sort of guessed as to what I needed to improve on, I think.
yeah.
So it's I think it's like a bit harder. It's like a lot harder with like because you're only getting like a binary pass fail, not even like how well you did.
Mm,
Like even if you passed or if you failed, like were you close or were you not?
yeah.
So I feel like at least for like technical interview skills, I've kind of sort of been just kind of constant throughout university. Like it's kind of just been like I go in, I do the interview, like I do the problem to the best of my ability, and just kind of hope I pass. It's
Mm,
kind of what I've been doing.
yeah.
But
Yeah.
it's interesting to sort of get input on this.
Yeah.
Or like
Let Go ahead.
Yeah, I think I want to ask like one of the questions I had again,
Sure.
which was like, when I'm jotting down ideas, would you recommend I jot down every idea that I have, or ideas that I think I'm good? Because I feel like if I went through trying to explain every idea, I'm like worried about like running out of time.
Yeah. Well, the thing is, yeah, I think you're really focused on how you're kind of tuned for doing coding competitions where you just implement as fast as possible.
Hmm.
Because you're trying to beat a certain time, right? But in the interviews, they're gonna
Yeah.
ask you two questions. Pretend at Meta they're asking like a couple questions in the span of 40 minutes, 20 minutes each piece. It only took you really 5 minutes to write the code. So you still have 15 minutes to explain your thought process, explain how you're going to implement the code and the interesting parts of the code, right?
Hmm.
So it's still you still have time to convey your ideas a bit more. So I think you don't need to write down every idea, but you just need to figure out what's important about the problem and write it down. So question one, what are the some of the important things? Using a
I
hash
like
map and
right,
using
right.
an array, swapping the indices, like maintaining the indices. That's the important part of getting it to O1. Like writing that down and getting to that and explaining it. Because I think you got there, but you just started writing the code right away, kind of thing.
Yeah. Yeah, I tend to sort of go into things with very little planning, I think, which I've noticed kind of. Um, yeah, I think it's a very good observation about the like about just kind of like the fact that I kind of just like jump into things.
Well, yeah,
Um,
you had the right direction, but it's just like I think I need to watch the tape over again, but that's what I would say. And it's honestly, it's mostly a nit or a chat. What's everyone thinking? Think, what's everyone else's feedback on it, real quick? Backtrack. Yeah, what's everyone thinking about the thought process feedback? I think that's also because that's mostly my main notes here. It's like just thought process.
time to stock chat now that the interview's over.
Let's see. Yeah, I guess they're not answering, but yeah. Um, Plasmatic, thank you for hopping into the interview. Probably they're gonna reply in a sec there, but yeah, one person makes sure the interview understands. But yeah, we can do this again at a different time. I'll watch over the tape and actually figure out what some good feedback. My main thing was about the notes, but yeah, how do you feel about the interview as a whole? Do you have fun?
I think it was pretty fun. Yeah.
Yeah,
Yeah.
cool.
I
Yeah,
think
good
I was
job.
kind of yeah.
No, like you
I think it
definitely
was
did
pretty
good. You
fun.
solved all three questions, two
Mm,
mediums, one hard. You should be
mm,
happy about the performance. That's a really
fair
good
enough.
performance. It's more just like yeah, I'm only giving feedback because we're just trying to figure out ways to improve too. But yeah,
Of course, yeah.
take it as you see. Yeah, cool. All right,
Fair enough.
I'm gonna pull in the next person. Plasmatic, thank you. Appreciate you.
Yeah. Thank
Talk
you
to you
for
on
having me
Discord.
on
No
this.
problem. All right.
Yeah,
See ya.
it's pretty fun.
Bye.
All right. Ciao.
So chat. So what are y'all saying? What's your feedback on Plasmatic? I said just thought process could be improved a little bit. Um, wasn't the biggest issue because I kind of knew the question or the answer already, but yeah, I need to watch the tape over again. All right, we got the next person. Cyclops, hop into Zoom. Cyclops, what's up?
Yo, what's up, man?
All right, let's get this.
You hear me?
Yes, sir. What's up? What's up? What do you
All
think of
right,
the last
cool.
guy?
He's crazy. Yeah, he's definitely crazy. Definitely like nowhere near
Yeah.
like that level right now, but I mean, it takes practice. So
So how many legal questions have you solved?
So right now, probably, so I've solved questions on like two separate accounts and combined probably like around 70. So I'm definitely more of like a baby leak coder right now. Um,
Okay, you
I guess
solved
like
70 questions.
yeah, like more or less, yeah, like in that range.
Okay, let me. I need to actually. Yeah, I need to ask these questions in order to get you some good questions. Actually.
Okay,
Um.
yeah, no problem.
Okay. Okay. So, what year are you in again? Actually, let me start. Let me start up the video real quick. And okay, three, two, one. Hey everyone, so today I got my friend Cyclops, and we're going to be doing a coding interview, a mock coding interview. So, simulating a coding interview that would actually happen at a fan company or like a startup that likes to ask lead code. This is going to be very lead code style. I know a lot of startups are starting to do practical. Maybe I'll get into those soon, but I just easier to just pull a question off lead code. So Cyclops, could you just walk me through your background so I could figure out the questions I should ask you?
Yeah, so right now I'm a grad student based out of New Jersey, and I'm kind of just prepping right now for like the fall like applications that will like open roughly like around like a couple months. Um, Kind of like the company scope that I'm trying to aim is like kind of in that range of like Datadog or like MongoDB or
Mm-hmm.
something in that range. Like not really like scope is kind of like out of or Fang is kind of like out of my scope. Like I'm not really shooting for Fang. I'm kind of shooting for like those types of companies like
Mm-hmm.
Datadog or something similar like Gusto, uh, stuff like that.
You don't want
Yeah,
to get into fag?
yeah. Like Fang's kind of out of my scope. Like, and it's not like that. I'm not applying to Fang. Like I still apply to Fang. No luck so far. Like, of course, like if I end up getting like a Fang position, then obviously I'm gonna take it for sure. But
Mm-hmm.
it's kind of like that's not really what I'm shooting for. I'm shooting for like more like medium sized like companies.
I see. Okay.
Yeah.
Let's see. So, do you go to a top school? People are asking.
Not really. I go to like a private institution in like Jersey. I'm like right on like the Hudson River.
Mm-hmm.
It's not like a huge school. Not like an NYU or like anything like that. Like a Columbia. Um, but I still say like it's a pretty decent school. I guess like if you live around here, you kind of know the
What's the
school.
name?
Stevens Institute
Nice.
of Tech. Yeah.
Cool. So your master's is in computer science.
Yeah, it's in software engineering, which is
Mhm.
basically the same. Yeah,
Okay.
it's the same thing.
Okay. What's your leak code breakdown? Easies, mediums, and hard.
By breakdown, do you mean like kind of like my comprehension of like the
Or
difficulties?
how many easies have you solved?
Um, Probably like maybe like 40 easies and like like high 20 mediums and like maybe just like a hard like here and there. Like I haven't really touched hards at all.
Okay.
Yeah.
How familiar are you with arrays? Give yourself a score out of 10.
With arrays, definitely like out of 10, definitely like a 7 or an 8. Like I have the fundamentals like pretty strong, but obviously like when it gets kind of like the question gets kind of like weird with arrays sometimes, so I could improve like in those types of questions.
Okay.
But yeah,
What about linked list?
link list probably like a 6.
Okay.
Yeah,
Trees,
trees like a 5.
graphs.
Graphs definitely like a 4, a 3.
Okay.
Yeah.
What about like BFS, DFS? I mean, that doesn't. Okay. What about greedy and or dynamic programming? I'll ask you that. Dynamic programming.
Dynamic programming. I haven't like really looked at them in
Okay. Okay.
dynamic programming
Like
either.
any
Actually,
not applicable. They don't really ask that too much in interviews, honestly. Binary search.
that like an 8 or 9. Yeah.
Okay, looking at this breakdown, definitely focus on arrays, but you need to get the trees and graphs higher because those are the most common that you'll see in interviews. So
Okay.
understanding trees and graphs are very important. Um, yeah, like every interview process I had, at least one or two of the questions was a tree or graph question. There's some array questions, but yeah, I would focus a bit more on that from just looking at the breakdown. But cool.
Yeah.
All right, let me look for a good question real quick then, and then
Okay.
I'll invite you to the lead code session.
Okay. Yeah.
Yeah.
Yeah, I think like earlier this month I kind of started like I looked at your playlist, like the lead code playlist, and I kind of started from there
Nice.
because like a few months ago I like had interviews and I was kind of naive and I was kind of like half-assing my studies or like
Mm.
my practice, and then I went into the interviews and I got cooked. And then when I got cooked, I was like, all right, well, I can't like half-ass it anymore. Like I need to actually lock in.
Yeah.
And like I had to, and I realized that like some of these like questions I was solving like a few months ago, like I didn't really understand the fundamentals yet. So I was like, I needed to just like stop what I was doing and I just need to go back from the beginning and like review my data structures, like, and kind of like every week I kind of loop the data structure like every day,
No, that's
like
good.
whatever
I think
like
what
learning.
your strategy is good of just focusing on like topic by topic and then improving from there.
Yeah, yeah. Like right now, I'm definitely like I'm just focusing on the data structure, like fundamentals or like the theory right now, and like I'm gonna try to apply it every day for like the month or two. Um, and I'll focus on like algorithms later, which is kind of like why I feel like I fall short right now in like the trees and such because like I'm kind of haven't really looked at like DFS or BFS too much.
Mm-hmm.
Like I feel like to focus on trees though, like you kind of have to know it. So I kind of like have seen it already a little bit, but like I haven't really put my focus on like the algorithms yet.
Have you written a DFS before or a BFS?
Yeah, like recursively, like I have
Okay.
and like BFS maybe like iteratively or so. Um but like with the more like complex like questions, like involved questions, like I probably would struggle for sure.
I see.
Yeah.
Okay, cool. All right, let's get this started. I'm gonna invite you to a lead code link. Wait, what's your
Okay.
lead code username? Is it your name or no?
It's just Cyclops, yeah.
Okay, okay,
But
just
let
make
me
sure. Yeah.
double check. Yeah.
Keep it anonymized,
Yeah.
which is good. Um, I'm gonna send you this. But like, even if you go into your username, is your name anywhere there or no?
Uh, let me see. Let me just double check. One sec. It doesn't look like it.
Okay.
Yeah, doesn't look like it.
Okay, I'm gonna send you the link.
All right.
I look a bit red. Let me fix that up. Um, bro, it's like this new camera is weird. Let me fix that up. Need to play with the temperature. This is my room. Oh, I look normal. Ramp up the brightness. What is this? Might be the saturation. Let me drop the saturation.
Okay. All right, I'm in here. All right. Okay, let me read the problem real quick.
All right, yeah. This is the first question. Yeah, go ahead and read through that question.
Okay. Yeah.
And yeah, take some notes on what you figure out there, or what you're thinking as well.
Okay. So, If true if and flowers can be. Okay, so just immediately like my thought process is so let's say we have this example here. Let's just this first one. So my immediate thought process is we can loop through all the indices, right? And we have this n is equal to 1 for this first example, right? So this is the amount of flowers that we must plant in the array.
Mm-hmm.
So if we loop through the if we loop through this list, we can check, okay, like if the positions like to the left and to the right are not like don't have flowers, then we can plant a flower at the current position. Like if the current position doesn't already have a flower in it, right? So here, like we already have a flower. I think the only thing that I would have to figure out is the edge case where like I'm checking like out of bounds here. So if I start here and I check to the left and to the right, then I'm checking out of bounds like on the left side. But for now, like, so that's like the immediate thought process. And then, so here I see that I have a flower. So I can't plant my flower here. So I would move on to the next index and I would see, okay, I see that this index is empty, but is the index to the left and to the right, are they both empty? Well, the one on the left is not empty. So I would have to continue to the next one. And then here I see that this position is also empty and the ones to the left and to the right are empty. And then I would go ahead and add a 1. Like I would replace this like value to be a 1. And I can decrement like my n value to like 0, right? And then I guess like once this reaches 0, this n value, then I can return true, right? And if I loop through the whole like list, and after if I check n, if my n value is not 0, then I can return false, because that means that I haven't planted all my flowers, which means it wasn't possible. So let me think of like how I can deal with like this edge case, like the left or the right. Injury is true. Okay. So I guess like if, for example, like if let's say like this is 0, because like a left value doesn't exist on the left here, but a right value does exist on the right, but but there's no flower on the right, then I'm able to just plant the flower right here, like on the left and right, like edges of the list, yeah. So I think like an easy way to solve that is what I would do is I can just modify like the list. I would modify this list and I would make like a new list, let's say, and I would add like zeros to both like the left and the right side. To kind of signify, so like if so I'm now like checking out of bounds, right? And I can check like, and basically this is basically a 0, like nothing on the left is basically just a 0. And yeah, and then so when I loop through all this, then if I check that, if this is 0, then I can return true or false otherwise, right? So that's my thought process.
Okay.
Yeah. So I'm not sure if that sounds good with you, but I can like go ahead and code it up.
Yeah, go ahead and code it up.
Okay. So let's see. So I want to see if I can just straight up just modify this like the current array that I'm given. So
I don't know if it's on your screen too, but I would write it into the function.
Oh, yeah.
Because sometimes it tweaks. Okay.
Yeah, you're right. Okay. So Let me just go ahead and like print this because I just want to double check that I'm actually like getting what I'm expecting. Okay, yeah, so that's kind of what I want. So from here, I can say, so for flower in the flower bed, right? Or actually, no, I have to search through the indices instead. So for I in range, the length of flower bed, we can say, and we want to start at, I want to start like here, right? I don't want to start here. So because this is just like a placeholder.
Okay.
So I want to start like at 1. And I want to go up to the length of this -1 because I want to end like right here. Like at the, like before the ending, the final placeholder, like on the right. Right. And then here I can say, if the flower bed at I is not equal to 0, or well, if it's not equal to 1, right? If it's not equal to 1, and flower bed at negative or 1 minus or I minus 1 is not equal to 1, and flower bed at I plus 1 is not equal to 1, then we can say, so if the current index is not 1 and the ones to the left and to the right are also not 1, then we can plant, we can decrement 1 because we know we can plant a flower.
Sure.
And we can modify the current index to say flower bed as I is now equal to 1, right? We just change 0 to 1,
Sure.
right? Otherwise, we just continue on with the whole like for loop, and at the end, after the for loop concludes, we can say return if n is equal to 0. Right. I believe like that might work. I think I can do a test run.
Yep. Looks like it failed
or
on,
like
on one.
So
Do a dry run. Do a dry run.
Yeah. So let me do a dry run. So, so for example, let's take the first example.
Let's take this example down here.
Okay. So let's do this. I'm gonna run it like within like the lines of my code here. So for in range 0, 1. So we start. Well, here we modify it, so we actually add like another 0 to the ends, right?
Yep.
Okay, so here we see, okay, so we start at this index 1, and we say if this is not equal to 0 and the one before it is not equal to 0 and the one after it is not equal to 0, well, and is 1, right? Yeah, so so I can just do, I replace this with a 1, and then we move on to the next one.
Or this is the solution or that one, it will work for that, but let's go through this one.
Through the one you have commented down here, right?
Yeah.
Okay.
It's like n equals 1.
Okay. Let's see, return true in flower. Oh, well, yeah, okay, so here we start at this position, we see, okay, it's equal to 0, and the left ones and the right ones are also equal to 0. Then we can change flower bed of I to be 1, right?
Okay, sure.
And we decrement this to 0.
Okay.
I think we can just straight up check, like, if this ever reaches 0, like within the for loop, then we can just like return true, like right away, actually, like within the loop. But we don't have to wait until it loops through everything.
Like right now, it's returning the wrong answer here. Like with your code, it will return false, but it's true here.
Okay.
But yeah, I just want to see if you could catch that. Like, why is it returning false? Why would it return false?
Because we're decrementing like past 0.
Yeah.
So that's why it's false. Yeah. Okay. So so here we can say, okay, so I just want to move this. So, and if like then we can just return true, right? And then here, like, if this ever exits, then we'll just return false. I think this will be fine. I believe that's why. So I think if I test it, if it just replaces this with 1, then it'll decrement. It'll replace it with 1. If n is equal to 0, we can return true.
If n equals to 0, return true. Yeah.
Otherwise,
there's like a weird edge case right here. Look at it. It's basically there's a weird edge case if n equals 0. Try submitting and you'll see.
Okay.
Can you try to debug that case?
Yeah, let's see it. Okay, well, okay, that was the edge case. Well, I think like before we even do anything, I can just check like if we're not planting any flowers, right? Then like we can just return like true right away, right? Because it doesn't matter like how the flower bed is like is. Yeah.
Cool.
Okay. Nice.
Cool. All right. Could you exit this one? And
yeah.
Just exit.
All right. Cool.
I'm gonna bring you to the next question. I'm gonna send it on Discord.
Okay.
Yeah. Good job on that, though.
Thank you. Okay. Okay. Let me read this question. So, if you're given n by n 2D grid, which represents the map of 1s and 0s of water, return the number of islands. An island is surrounded by water. It is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. Okay. Okay, so I think the first the first like immediate thing that I noticed is that this is kind of like a BFS question, and let's see. Give me another minute to think about this. Actually,
what are your thoughts so far, or like what did you get out of the question that you think?
So I think this is like definitely like some matrix like BFS question, and I think that so horizontal or vertically. So right, so let me go ahead and let me take this like this matrix from the results or the examples. So so like if we start like let's say like we start from the top left, we can check like all the values like to the like up, down, left, and right of it, and check like okay, is it still like an island or we've reached like water, right? If it's still an island, then like we can continue the like traversing like with the BFS up until like we've like reached like all directions that are water. And I guess like we can keep like, so it doesn't like loop forever, like go up and down like and left and right forever. We would keep like a visited like hash set, where we can keep our scene values like in here, right? The one edge case that you would have to keep in mind is that if we're ever like at an edge of like the matrix, we can't like traverse like out of bounds.
Mm-hmm.
So you would want to always check like if like when we're traversing, you always want to check like to not like traverse like out of bounds. And then I guess like to do that, we would have to like keep the length of the grid, like using like two variables called like row and column, and we can have like one is like grid, one is like grid of 0, right? And then to make it like really easy with this BFS, I guess like, we can also like initialize like some directions like variable, and this is like where we can like so like when we're doing the BFS, we can call like this direction, so we don't have to write like up, down, left, or right like within the loop. Like we can just call this, so like we can have like we can do like this. So this is like signifying like to the left, to the right, to the left.
Okay. The DFS part makes sense. How are we gonna count the number of islands?
So I think like how we would count it is, I think like once you reach like so once you've kind of like explored all like the indices, and like we can like keep exploring anymore because it's either like water or it's like invisited, right? Then we know that like this like the island is like, we're already like at the limits of the island, like it can't go any bigger than this. So we know that this whole like section is one island, like a single island, right?
Yeah.
And then we would like keep like like islands counter, and we would set this to 0 at the first, and then we would increment it with whenever we reach that like case, right?
Okay, go ahead and implement the code. Looks like you're going the right direction.
Okay. Okay, so let me just see. So okay, so first let's just do like our rows, or let me just make sure that I'm in the in the function first. Let me just do it up here. Sure. So rows and columns, right? We can have this equal to, this will keep track of like the size of our like matrix. We can do the directions, and let's see, we can do like or actually let's just, I don't want to do like tuples, let's just do like a list. 1 0. Okay, so like whenever we want to go to any horizontal or vertical direction, we would call this this list, right? And we'll do like a visited is equal to like a set. So this will keep all of like the directions that we have already seen, so we don't revisit them. And we'll have like a num islands counter, and this is like what we're gonna return like at the very end of our like call like BFS, right? So so how I think I want to do this is I maybe want to I maybe want to like define like a helper function within this function. And this like helper function will take like the row and column that we want to like that we're currently at, like where we're like we want to traverse basically. Like before I write that, let me just like so let me just like do the loop. So like for the traversal, so like when we have to call like this helper function, right? So to traverse through this matrix, we can do for R in the range of rows, and then for C in the range of columns, we can say if this current matrix that we're at, if it's not water, so if it's equal to, these are strings, right? Yeah, so it would be this. So if it's not water, if it's an island and we haven't seen this position in our visited like list, then we can
JN, thank you.
We can call like our helper function on with these two like indices, right? And then let me just from here let me write the BFS actually. So the BFS we're gonna use like I want to use like a double-ended queue, so we're gonna just like import our
for this question, do we want to do a BFS or a DFS?
We want a BFS.
Okay.
Yeah, so I want to do a BFS. I guess like yeah, I want to do a BFS because I want to like from the like the queue, right? I want to like pop from the left side, so that's why we're doing like a deck here. Okay, so okay, so we'll just call our queue like queue, and we're gonna go ahead and we're gonna append these two like indices to our queue like right off the bat. So we'll append these two, and we'll also append them to the to our like visited set. I believe it's like dot add to add them. Yeah. Okay. So from here, what I want to do is so while there exists like a queue, right? So like while there are like positions that we have to visit in the queue, we're gonna do well, we're gonna pop from the left side. So we'll just say like current like row, current column is equal to queue dot pop left, right? And then from these two positions, I want to call like this directions like list, because from these two directions, I want to traverse like both up and down and left and right.
Sure.
Right. So I guess an easy way to do this is, so what we can loop through this like list that we have up here. So we'll do like for directions left or directions row and directions column and directions. We can how we're gonna do is we're gonna add this and this, and we're gonna add this and this basically. So like to go up, down, left, and right. So and then we'll save that to like a new we'll save that to like a new thing called like new row, new column, and then this is equal to current row plus like the direction that we want to like traverse, and then the new column is the current column plus the direction of the column we want to traverse. And then so from here we can just, so here we're traversing basically, we're checking the new we can use this to check the new like positions, and we can say from here we can say, well, first we want to check like if we're not out of bounds, right? So because we could be like on the edges of this grid and we can go out of bounds. So I guess like in our if statement we can say, so if new row is in like the range of rows and new column is in the range of columns. Okay, so that checks like if we're in bounds basically. And now we want to check like if we're checking an island, we're looking at an island. So we can say and grid add new row and new column is if this is equal to 1, and this and we haven't already seen this, right? So we also have to check and if this new row and this new column is not in our visited. So if it's not in our visited and it's an island and it's not out of bounds, so we can take this like new position that we just found and we can add it to our queue actually from here. So we can do like we can do new row and new column, and then from here we can also append it to our visited like hash set. So we can do new row, new column, right? And then I think what happens is this gets called like this continuously like gets called on itself because like we will keep having a queue until one of these conditions is not met. So once it's not met and like the queue ends up being empty, that means that we've traversed like the whole island that we're looking at. So that means, so I think like once this BFS gets like returned, like the call gets returned, then we can go ahead and I think we can just increment from here like our islands count, right? And I think if everything is okay, nice. I think I did that fine.
Cool.
Okay.
Yeah. You got it implemented. Let's see. Yeah.
And time and space complexity. So
yeah.
Time complexity is just m times n, which is like the size of the matrix, because we could possibly traverse like every element in our grid. And space complexity is also like the size of the matrix, because we have this visited like set, and this can keep like at most it will keep like every element, I suppose, like in this set. So we're using space in this sense here. Yeah, I think that's good.
Cool. All right.
Okay.
Nice work.
Thank you.
I'm just looking at one piece of code. How I think this range function might be inefficient. It will generate rows between, or what is this doing right here?
So this is just checking like if it's in the range of like our length of like the rows. So if it's like out of bounds, so if it's not in the range, that means it's out of bounds.
I see. But for each iteration, it's generating a list here, right? It's creating a list of 0, 1, 2, 3.
Okay.
That's what range is doing under the hood, right?
Yeah. Okay.
And same with calls here.
Okay.
How can we speed that up?
So I think we can just check like if. So I think instead of calling range like of the rows, we can just straight up take this like we can take rows, which is like the length of the grid, and I think we can say like if instead of doing this, we can say if this is between like 0 and new row, and then I think something like this. I think. So if 0 is less than new row. I'm just trying to like imagine it in my head right now. This is right. Something seems off about this. If 0 is then we can do this. And then this could possibly be 0. So this is fine. So if it's less than or
Well, let's just break it down into like
yeah.
this. Let's be like, or yeah, like if new row, like the different conditions, if, and then if it passes, if it breaks that, just continue. That's the way I like to break it down. Like we can separate this out further. So if not in bounds by row, continue. Because you're trying to do it all in one line there, and it's kind of messing you up a bit. If
Oh, okay. So you're doing it like you're keeping all these conditions like on separate if statements, and then you're just continuing if it's like none of them are,
yeah,
or
if
one
it
of them
does,
is
it's
not.
easier
Okay.
to usually say like if it doesn't meet this, continue. Versus you're trying to do like if it's in here, but then you'll have to take a not. If it because here you're saying it should be like if not new rows in between this, right?
Oh
Not
yes,
so
yes,
that's
you're
why it's
right.
confusing you a bit. So that's why
Yeah.
another way is to do this. Yeah, try it both ways.
Okay. So um, so I guess like let's like split up this. Do you want me to like split it up into like 4 different if statements, like this whole like line
No, just
basically?
the bounds check, right?
Oh, okay. So here, so if not 0 less than or equal to new row, which is rounds minus 1, and we can also do that. We can do this again, but for the columns. So new column, and then columns is 1 and continue. And then here we can reduce this line, and we can just check like this thing right here. I think that's what, and
Yeah.
I'm not sure if this. Let me just actually submit this or like run this because I don't know if my thing is correct here.
You have off by 1 here.
Yeah, I see it. Okay. Do I even need this actually?
I think that might be it. Nice.
Okay. Yeah.
Yeah.
Okay.
Cool. Yeah.
Yeah.
Just now that's ov 1 check there now. Which is
Okay. Cool.
like yeah, just the different ways to break it down. Yeah. Overall, really good job. Like for only solving 100 questions. How do you think you did first?
I think I actually did pretty decent. I think like I definitely like I definitely needed like I missed out maybe on some edge cases like on the last question, or like the like with the n being like equal to 0, then
Yeah.
we don't need to plant anything. Like I missed out on that like right away.
Mm.
For here, I think I'm actually surprised that like I got the whole like code for this like working like right off the gate.
Yeah.
And I think overall like I explained my thought process like pretty well like in pseudocode for the most part like before coding.
Yeah.
So yeah, I think overall I think I did pretty well.
Yeah. Let's see. Let me see my notes. Yeah, I think you did good. Good thought for both questions. Good thought process. Code is super clean. I like the way you structured it and the code was clean. I think first question you solved pretty easily. You did run into those edge cases, but you're able to figure them out. I think
Yeah.
yeah, like you implemented BFS, well, I would just say the main thing is just getting more reps and timing yourself and get it faster. I think it seems like you might have not implemented BFS in a long time,
Yeah, it's been a while. Yeah.
so you're still able to solve it, but in the interview, you should get it faster. Um,
Okay.
but I think that you still did really good to pass. Like that would be a pass on the interview. This is more just like for training
Okay.
because some questions it might not be straightforward, so you need to implement BFS way faster than that because there's other intricacies in the problem that you need to handle with. So if I added a twist to it, or there's a twist to the problem, you would have might have not solved it in time, right? This
Okay.
one is just like just straight DFS. So I would just make sure to be able to implement BFS a little bit faster. So if you have a question that's a twist to BFS, you could spend more time thinking about the question, then you could just like spit out the code really fast. That's kind of my main thing. So I think yeah, overall, I would just keep doing the interviews the same way you did it. You have a good thought process and writing the code. That was really
Okay.
good. I would just make sure to keep doing what you're doing. The main thing is just take on harder and harder problems and get them done faster and faster while maintaining that same thought process. That's gonna get you because now you just need to get better as well. Or like keep doing harder questions. I think in the
Yeah.
interview they're actually gonna only ask you questions that are slightly harder, but you want to be able to do harder questions so that you never fail an interview. And I think you can get there. You have like the good foundation.
Okay. Cool.
Yeah.
Awesome. I guess like actually I have like a couple questions like when it comes to
Sure.
like practicing and stuff.
Mhm.
Um, so like in your playlist, like when you said like maybe focus like a month to a month and a half on like data structures only and like
Mhm.
save like the next like month and a half for algorithms. And then from there you kind of like start grinding like the questions like straight up.
Yeah.
So I mean like when you're like when I'm studying for data structures, like let's say if like I'm studying trees and like the ideas, and like I kind of like I understand for the most part like most of the theory for like all the data structures and like how
Mhm.
they work. But like once I start like let's say like practicing tree questions and like solving them, there's no avoiding like having to learn like a BFS or DFS like trying to practice trees.
Yeah.
Like I'm just gonna have to learn it. Like even if it's not like my month of algorithms, like I'm just gonna have to like look at it.
Yeah.
um okay.
I think yeah, definitely. Okay, yeah, when I said learn the data structures, actually, have you tried implementing a tree from scratch?
Yeah, actually, yeah, I did.
Nice, yeah. So try to implement the different data structures from scratch, and then I think
Okay.
DFS and BFS are common patterns for them. But things like
Yeah.
sliding window, two pointers, cyclic sort, using two heaps, topological sort, those are more specific patterns. So probably the basic ones you should even know, like two pointers, probably hash maps, all that stuff.
Okay. Yeah.
But then if you don't know topological sort, that's fine, unless you run into a question where you need to learn it. But I think
Yeah.
when you're focusing on data structures, right? Try implementing from scratch and then learn the basic patterns for those data structures. And then what I mean, like when you're grinding patterns, right? So patterns, one pattern for graphs and trees is topological sort. It actually comes up pretty often. Have you heard of that pattern?
I have, but I haven't even looked at it, so
Yeah.
I'm like
So
avoiding it right now.
when you learn topological sort, you do like 5 or 6 questions using topological sort, essentially. So you start to see all the different questions where topological sort will be used, and then you grind out like learning how to actually implement it fast. So those ones are like when you're going into patterns, those are the ones that you're gonna be. Does that make sense? Like grinding out
Yeah.
harder.
Yeah, it's kind of like yeah, because right now like my study, like the way I study is kind of like I spend a week and a half, right? Like I'm
Mhm.
studying data structures, and every day I kind of so day one is like arrays, and day two is like the next data structure, and day three is like the next one. And then once I go through everything, I kind of loop back to arrays for the next week, like for the new week, and I kind of go from there for like a month and a half. But it's like some data structures like trees, for example, or like matrices like this, like I'm gonna have to know like to practice those data structures. Like I already have to know kind of like the common algorithm already,
Yeah.
which is like BFS and DFS. Yeah, which was
Okay.
kind of my question. Yeah,
Sick.
yeah.
All right.
Okay.
We should actually do one. We'll do one maybe next week or the week before. I'll message you and we can wrap up the questions. I kind of see where I kind of want to see where you're at. I think you solved these ones easy. I could give you slightly harder. I want to see, yeah, sort of where you're at when it comes to how hard the questions are. But I think what you're
Okay.
doing is perfect. Like you're grinding it, you're getting good. I would just keep it up.
Okay, cool. All right, thanks so
All
much,
right,
man.
thanks,
Appreciate it.
man. All right, okay, see you. Peace.
I'll see you. Peace.
Okay. Yo, you did pretty good. That was a fun one. Jan, yeah, just message me. Yo, Alex, what's up?
Yo, hello, can you hear me?
What's good? How you doing?
How's it going?
I'm good. I'm good. So, were you the one that said no trees and grass?
Oh yeah.
Okay. All right. Could you give me like a 5 minute break and then we can hop in? Do you have a hard stop at the top of the hour or no?
Wait, what'd you say?
Do you have a hard stop at the top of the hour?
Oh no, I'm free.
Okay. So let's take a 5 minute break quick, or let's take a 7 minute break, just to rest real quick. So yeah.
Okay, sounds good.
All right. Okay. I'm gonna go on mute. I'll talk to you in a bit. Yo, chat. Gonna take a quick break. Give me a sec. Put another question. Alright, I like this video. So I'm taking a quick break and I'm gonna answer the question: is the 10x engineer a myth? Is 10x engineer a myth, or is it something that someone could actually achieve as an engineer? And if you never heard this term 10x engineer before, I didn't either. The first time I ever heard this term was when I first moved to Silicon Valley, and I was working at it was like an early stage Series B, and then I was working. I pulled a late night that night, and then my CEO was also pulling up a late night, and he's just basically like, if you at this rate, like if you keep working like that, you're gonna become a 10x engineer. I thought about it, I was like, wow, that's a pretty cool term. Like that sounds like something you want to achieve, right? And then after I heard 10x engineer, essentially what 10x engineer means is a 10x engineer is a software engineer who is 10 times more productive than the average engineer. So take the average engineer, and a 10x engineer is someone who's just 10 times more productive than like the average engineer. Um, and for some reason, 10x engineering, like people like debate if this is even possible. They're saying that it's not really possible for someone to be a 10x engineer, and that's kind of a myth. Um, like, if you just look up 10x engineer here, you'll see, like, is it really possible to be a 10x engineer? This one says like the 10x programmer myth. Like, and you just get into conversations in the Bay Area of people. Well, that's the only place I've worked. So people are always like, no, it's not possible to be a 10x engineer. I don't know if they're just trying to be nice, but I think you can be a 10x. I think it's very, very, like, very possible to be 10 times better than the average engineer. You can even be 100 times better than the average engineer. You can be like even way more than 100 times better than the average engineer. Maybe a 5,000 times better. You could be a 5,000x engineer. And yeah, like for example, when I used to play basketball for when I was growing up, and no matter how hard is Kevin Durant 10 times better than me? He's way more than 10 times better than me at basketball. And I was practicing basketball and training basketball since I was a young kid. And no matter what I can do, he's still going to be like at least 500 times X better than me. So it's possible to be 10x more productive than the average engineer. I don't know why it's debated, but yeah, I pretty much this is just a random thought that came to my head. You could be a 10x engineer, you could be a 100x engineer, you could be like 100,000x engineer, compared to some people. And that's not to scare anyone off, to be like there's people out there that's gonna be 100 times better. It's more, I would say it's more just for motivational purposes. Like when you see someone so good at their craft, you know that there's just room for you to improve, and like there's no limit to where you can take it. I feel like with things like basketball, like your height kind of plays a factor, but I feel like with coding or software engineering, there's less of a ceiling physically. Um, Maybe there's one mentally. I don't know if they did studies on that, but I feel like I did a video on natural talent versus hard work. I feel like if you just put in the hard work, you can be 10 times better, like 10x better than the average engineer. You can get 100x better than the average engineer. You can build a feature in a week that someone will take a year to build. Honestly, I've seen that. Like I've seen people push out code and feature or projects so fast, and I mean these projects are so complicated that the average engineer couldn't even solve that project. So does that make them 10x or 100x better than that engineer because they're able to pump out projects that like an average engineer can't even make? I feel like that's even more than 10x. That's like, I mean, you can't even compare it. There's just no compare, like there's no magnitude of that. Like if someone can't even get that project out, even if they spent 5 years, maybe they have to go back to school in order to solve a project like that. But then somebody is able to do it in like less than a year. I mean, that's pretty crazy. And yeah, that's kind of my thoughts. I mean, like you can be 10x better than someone like someone, yeah, I don't know. That let me know what your thoughts are on 10x engineering. Is this thing real? I think it's real. I mean, if you think it's fake, just let me know why in the comments. But yeah, I don't know why people debate this. If you are an engineer, um, I don't know, maybe the new term that kids are gonna be saying these days is like cracked engineer. Can you be a cracked engineer? I think cracked engineer is way easier than 10x engineer. Cracked engineer probably chat back. Yeah, Alex, what's up? Can you hear
Yo.
me? Yo, what's up?
Yeah.
Let's see, 10x is great. Yeah, I was just take a quick break. I was just listening to that's it. I did this video. Is 10x engineer a myth? Are you familiar with that term?
Me?
Yeah. Have you heard of that term? 10x engineer?
Uh, I think so. Isn't that just like when someone does the work of like 10 people?
Yeah, it's like somebody who's a 10x engineer is somebody who's 10 times better than the average engineer.
Mm.
Where are you based?
Oh, I'm in New York.
Okay. Yeah, it's a big thing in the Bay Area. People are like trying. You'll see it in job postings. Only want to hire 10x engineers and stuff. It's pretty funny.
Oh, is that you?
Can you hear me?
Yeah.
Am I 10x?
Oh, is that you? Are you a 10x?
Nah, I'm trying to be, but I think it's a lot of people these days. Though they say that 10x engineering is a myth. There's no such thing as a 10x engineer. What do you think? Is there such thing as a 10? Do you think someone could be 10 times better than the average engineer?
Like at the same company?
Yeah, or like in general.
Why not?
Yeah, exactly. That's what I think too. So, well, the better question is, do you want someone to actually be a 10x engineer in your team? Which is a valid question. Is like, why is that guy doing 10 times more than the other people? Is he just 10 times more talented? Is it possible? It's just philosophical stuff. But all right, let me fix my All right, wait. Let me just check that my lighting's good. How you been though?
Good, how are
Studying
you?
for some stuff. I'm good. I'm good. Let me check my. What are you studying for?
Like right now?
Yeah.
Oh, I'm just doing school. I've been like trying to get back into LeetCode because trying to get like an internship fall or something.
Yeah, I see. Are you're just in school still, or it's summer break for you?
Yeah, I'm a junior, so we still
Second
have
year
like
student,
half a
I
year.
guess. So you're
Third year,
second junior, second year, or third year? Third
third
year.
year.
Okay, I see.
Yeah.
I see. All right. Okay, I'm gonna ask you some simple questions to get a breakdown
Okay,
on
so cool.
your on um basically figure out what I need to ask you. Cool. One sec. I'm gonna shoot this as a dedicated video, so I'm gonna do a little intro. Let me see. One sec. Fix my screen. Do you hop on the streams a lot? Or you new?
I've seen your videos,
Nice,
but I haven't really like tuned into a stream yet.
nice. All right, cool. Welcome to the stream then.
Thank you.
All right, okay. I'm gonna start this up. Hey everyone. So today I have a student from NYU. He's a sophomore. I think he's preparing for his interviews. Probably goes. NYU's a great school, so probably can get an interview at pretty much any company. So I guess at this point it's just making sure your lead code skills and interviewing skills are up to par. Can you quickly give a quick background on yourself, by the way? Maybe
Oh yeah,
just
yeah.
like what school you did, maybe if you did any internships, how many lead code questions.
Yeah, so I'm third year at NYU, and I've done like I think like just under like 100 easies, and maybe like around there for mediums as well. But I mostly just started like beginning of this year. And then as for internships, I did one freshman year at like a semiconductor company, and
Mm,
then one this past winter at just like a startup, and then
nice,
this summer I'm gonna be at Square.
nice. So no, you haven't done any hard questions.
Hards, not really. Like if there's like one or two interesting ones, I'll like look at it, but I haven't really tried to like do it
Cool,
myself yet.
cool. So your third year at NYU, right? That's in New York.
Yeah.
Okay. What companies are you targeting for maybe when you graduate or your next like, recruiting cycle?
Uh-huh. I was thinking maybe some like fintechs or like unicorns. Um, like maybe shooting high for something like Stripe or like Airbnb or something. But
Nice.
yeah, I'm just trying to like get my lead code up. So
Okay, cool. So how are you with a raise?
I think I'm fine with the race.
Okay. Give yourself a rating out of 10.
Maybe like 7.5, 8.
Okay. Um, link list.
Ooh, not really. Haven't been studying those, so probably like a 4 or 5.
Okay. Let me think. Trees.
Same thing, yeah.
Four or
Haven't
five.
really looking
Okay.
those yet.
Graphs.
Same.
4 or 5.
I feel like I'm trying to
Oh yeah,
get
you're
back
trying
in.
to avoid trees and graphs. You know for sure they're not gonna ask you trees and graphs because these are the most common questions that they ask trees and graphs.
Or no, yeah, like right now I'm just trying to because I'm like easing back into it. I'm gonna
I
like
see.
kind of dive into that more, but focus on everything else first.
Okay, so you just want more of a raise. What have you practiced so far that I could ask you?
Uh, I've done a lot of like I guess like hash maps or like arrays or like things like that. Probably mostly arrays. But I haven't done it for a little bit, so.
Okay. Hash maps and arrays. Okay. All right. Okay, I think that's all the information that I have. I'm gonna quickly pull up a question. Uh, Are you in the stream right now? Or no?
Yeah.
Oh yeah, hop out the stream so I can get you a question. Just
Okay.
so you don't see the notes and stuff. Let me think.
Is it on like LeetCode or?
Yeah, I'm gonna ask you a lead code question.
Cool.
But like, what's your username on LeetCode? Is it anonymized or is your actual name and stuff?
Oh, it's my actual name.
Okay. Do you mind or should I ask you a code? I can put you in a code.
Hold up. Or I could just like make a new account real quick. Like just sign it with another email.
Let me see. Wait, let me create a pen.
Let me just do that. I can just sign it with another email.
Okay. Simultaneously, I can just try to quickly create. We can maybe go off quarterpad.
Yeah. Yeah, I have another account now, so should be good.
Okay, sick. So yeah, I'll ask you a couple questions. They're like easy question, tagged easy, but they might be a little tricky if you solve them really fast. We just move on.
Okay, sounds good.
All right, I got the first question. I'm gonna send you an invite.
Cool.
I'll put in this chat right here.
Got it.
Cool. Nice. Yeah. Go ahead. So go ahead and read it and let me know what your thoughts are.
It's the valid palindrome, right?
Yeah.
Cool. Cool. So we're given a string s, and then we want to return true if it can be made into a palindrome after deleting at most one character. Okay, so looking at the test cases, s equals ABA, and we just return true because it's already a palindrome. ABCA, and then we also return true since deleting C gives us ABA. And then number 3, ABC return false because we cannot make a palindrome. Okay. So I think my initial approach to this might be like taking a similar direction as the original problem where we use like a 2-pointer, but this time maybe if we run into like a disconnect, we can like try to skip that character, and then if we run into the same problem again, then we just return false.
Okay.
Let's try that. So let's set left and right as the indexes of like the last and the first.
Mm-hmm.
Also, first of all, if s length is 1, we can just return. So if length of s is 1, we just return 2. Otherwise,
your typing is louder than your voice for some reason. I don't know.
Oh really? Maybe. Hold up. Is this better?
Let's see. Type.
Wait, I have a keyboard on top of my laptop. 1 second.
Okay.
Yeah, so left right equals 0, and then
that's better. Yeah, for sure.
All right, cool. So let's make the like 2 pointers to the beginning and end of the string.
Sure.
And then what we want to do is maybe like try to keep iterating to the 2-pointer until I guess the left, while the left is still smaller than the right. And then we do let's check if the characters at each pointer are the same. So if s left equals s right, we can just so left plus equals 1, right minus equals 1. Otherwise, what we want to do is maybe at this point we would have to choose between either skipping the left or right, and since we don't have access to like the rest of the string, we are not sure what to do. So we could maybe return like something where we have both the left and like check the left and the right. Maybe we could use like a helper of some sort, and then return something like valid helper string the left +1 and right, and or valid helper string left right -1.
Mm-hmm.
And then for that, we can just fill that in here. Or we don't have to pass in the string then. But with that, it would just be like the same thing, I guess, like while I less than, or while left less than right. We just do if s left is not equal s right, then we just return false. Otherwise, we increment them. And what this should do is like when it hits like two different characters, it like returns true if like either skipping the left or the right one gives us the right answer.
Mm-hmm.
So let me try to run this. Oh, maybe no. Oh, if we skip through this, we just return true. ABCA return null. Oh, oops, I have to put it here too. My bad. Okay, looks like that worked. I can try submitting it.
Nice. Is there any way to clean up the code a little bit?
Some code, yeah. Let me see. We could just like have it outside of the main function too, but let me do this actually. This doesn't change anything, but I'm not sure if there's like a better way to solve this, but I think like in either case you would have to check like both the cases, like skipping left or right.
So why do you have to check both cases?
Since you don't know like at that index like whether the left or like the right is the one that's the odd like character out.
I see. Yeah. Okay, that makes sense. Yeah. Code's working. Good job. Pretty fast on that question. Let's move on to the next question. Could you leave this question?
Yeah. Okay.
Just end it. Yeah. Okay, I'm gonna send you the next one. Nice, Sharon. Okay, yeah. I'll let you go ahead and read that.
Cool. Yeah. So we are given an array asteroids of integers representing asteroids in a row. So indices of each asteroid represent their relative position.
Yeah.
And then their absolute value. So the value of the element represents its size. The sign represents its direction, positive meaning right, negative meaning left. And they all move at the same speed. So we want to find out the state of the asteroids after all collisions. If two meet, the smaller one will explode. And if they're the same size, both will explode. And then two asteroids moving in the same direction will never meet. Okay. Let me see. So for the first example, we have 5, 10, -5. So let me see. Okay, so that means the 5 and 10 would be moving in the same direction. So they never collide. And then the 10 and -5 collide. And then since the 10 is greater, it's magnitude, right? So it would just result in the 10 staying. And then 8 and -8, they never, they do collide. But since they're the same magnitude, they both are removed. And then finally, the 10 and 2 don't collide, but the 2 and -5 collide. resulting in -5, and then the 10 and -5 collide, resulting in 10. Okay. So since we have to like still like maintain, I guess, like information regarding like every element, even if like the elements that like the indexes next to it like don't interact, like let's say 10 and 2, since they don't collide, we still have to maintain like information about 10, since down the line like it could collide with something like -5, right? So to do that, maybe we could use something like a stack, maybe. And then maybe have it so like while the like top of the stack is the same like direction as the next asteroid, we like just append it to the stack. And then otherwise, once it is not, say like we have 10 and then we add 2 to it, once we get -5, we deal with that interaction then. So let's try that. So for asteroid and asteroids, let's do while asteroid we can do like if stack and stack -1. Okay, so we have to check if they're the same like parity, but to do that, okay, I'm blanking. Well, we can just check like for positives for now. So like, or for negative. So maybe like while stack, like let's say we run to a negative, and so while it's valid and the asteroid is less than 0. So let's say we have like -5, and then like let's say we have a positive, so that means the last index would be greater than 0. So while like the next asteroid is negative and the stack is like the top of the stack is positive, we want to check if the like the magnitude of it's greater. So if stack -1, so if the one existing is smaller than the current one, then we can just pop. So stack.pop. And then otherwise, like if it is greater, so let's say like here, right? So it's -10, -5. Since 10 is greater, or like the last one in the stack is greater, we just disregard the current like asteroid. So we just continue, I guess. And then okay, so what if we start with a negative though? So if we get -5 in here, like the first one's -5, we skip this since it doesn't exist. We would just, let's try that first. So stack dot append asteroid. Let's look at the first test case. So 5, if we get 5 in here, we just append it. And then next one, since 5 is not less than 0, we just append it again. And then if we get -5, we go here. And since asteroid is less than 0 and also less than 10, we check this. And since it is not greater in magnitude, we don't pop it. And then, okay, never mind. We don't do this. We don't append it. We only append it if it is
Maybe easier if we actually write it down, like simulate the stack. Right.
Yeah.
Just walk me through now. Okay, you're gonna put 5 in there,
Okay.
and then yeah, just dry run it now.
So we put 5, and then that stack would get we'd have 5, and then once we run into 10, same thing. Since it doesn't go through this while loop, we also append 10.
Sure.
And then when we get -5, we do enter this while loop, but since it is
Like, why do we
rest,
enter the while loop?
since asteroid is less than
Less than
0
0.
and less than like 10.
But is 0? Okay, 0 is greater. Like the condition is a bit weird. It's like asteroid is less than 0 and less than 10. Okay. I see. Okay.
Let me check. Since if it's like not negative, so like if we're only holding positives, right?
Yep.
If it is not negative, then we can just append it directly here.
Yep. Okay.
Otherwise, if it is negative, we want to check if it is greater than the like top of the stack. And while it is greater, so let's say we have like 15, like -15, right? Then this would pop 10 and then pop 5.
Yep.
But I'm kind of messing with this because, like, let me see. Let me just try to make it work for like positives first. So like only showing positives. So if it's less than asteroid, then we pop. And then oh, let's also check. So in this case, it's like breaks asteroid like on top of stack. Otherwise, like if it's the same, so same as asteroid, then instead of like continuing to iterate through, we would just pop it, and then we would break the while loop, since the like negative asteroid also like explodes.
Okay.
Oh no, this is only if it's like equal. So elif asteroid or negative asteroid equals stack -1. Okay.
Okay.
And then I think that should work. Let me give it a run and see what happens.
Let's do a dry run. Like don't run the code yet.
Okay.
Right. Let's do a dry run.
Yeah.
Let's start empty here and then dry run me through how this is gonna work for this example. Right here.
Cool. Yeah. So first we have 5, and we just skip this since stack is empty, and then we append it. So stack becomes 5, and then when we have 10, we do go into this part since like stack exists, but since the asteroid is greater than 0, it's positive. We just break out of the while loop and then have 10. And then now that we have -5, right? So now that we have -5, this condition is met. And then since neither of these conditions meet, we just should like break out of this while loop. Oh, we shouldn't add this. So we'll just do else, meaning that it is we should just continue. I think we should just skip like appending it. Like -5, we should just move on to the next asteroid, since like it doesn't affect any of the ones currently in the stack.
Okay. Well, we're still gonna append it here, right?
Oh yeah. Or doesn't this continue like skip to the next one? Like the next.
Well, it's the continues within this while loop.
Oh right. Okay. Else and then we can just
So which one are we looking at right now? Like, what's the issue?
I don't think this works either, since what we want to do is like if it breaks the asteroid on the top of the stack, we should just like so what this does is like if the asteroid is greater, we pop the top of the stack and then we continue to the like we continue until it is
That makes sense. Yeah.
okay. And for this one, what we do is if it's the same, we pop the top of the stack, but then we break since we don't want to consider the rest like compared to the rest.
Sure.
And then otherwise, like the third case is if smaller than asteroid at top of stack, then we just ignore it. So we can just like break out of this, I guess, and then we can just like move this.
Like, what's the main issue now? We're just adding the asteroid. Asteroid is, even though we shouldn't.
Yeah, we shouldn't add this. So maybe we should move this like up to break top, else pop break. So we only append it if like this case like is the last one.
Yeah.
I'm kind of blanking out. Like, is there a way we can just like break out of this whole thing? Otherwise,
okay, bring back that line of code that you had.
yeah.
Okay. So like, when do we have to do this? When do we want?
So we only do this if it like breaks the asteroid at the top of the stack and like where it's like all cases besides these two cases. Like besides when it's the same since it disappears, or if it's like smaller so that it disappears as well. Like otherwise we continue doing this until like either the stack is empty or like
Yeah. What about we just break it until, pretend we have an asteroid right here, like negative 5. Like we have -5, right? We just break it while it's strictly less than, or we break it while it's strictly greater than, like the absolute value is strictly greater than the thing that's greater than the stack. But if it's equal, then we stop and then we handle that case after. So we kind of
so we just keep breaking it until like
till we're less than or equal to. Right. We break it till, so basically when we get here, we're less than or equal to, like the absolute value. Is less than
that makes
or
sense.
yeah. Okay, I'll let you go from there.
Let me check this logic. So while stack and while this is here, the first thing is if it's like this, we just pop. Else, if it's like this, we just or we don't need a. Oh wait, no, we do need a pop. So we break, and then else we pop, and then otherwise we just append, right? Like outside of here.
Let's break this into two sections, like pop out of stack all values less than absolute value less than. Pop out of stack all asteroids that will get destroyed, right? Handle that case first. Like simplify this code a bit.
Oh right, like if we don't do these cases, we won't even need to like append it. I mean sorry, like if we do this case, like if this case succeeds, we like don't need to append it. So we can just write like an else like statement outside of the loop, right? So like while this, if like this condition is not met, then we append it. Otherwise we can just pop or like break or anything. So the first thing is we check if it's like if we have to consider destroying like anything within the asteroid, and if not, so like example, if it's like positive or whatever, we can just go ahead and append it. So we can just do like else stack dot append asteroid, right?
What is this else on?
It's like if this while loop is not like the conditions aren't met.
Okay, but there's no if statement that goes with the.
Oh, I'm pretty sure like while like also has an else. Like if this is not met, it treats it as like an if statement.
Let me see. Is that
Can I try?
is that how it works? Oh, I didn't know that.
I'm pretty sure. Like, I think I've used that before. Okay, let me see. So 5, 5, 10, 10, 5. Okay, so we're appending it incorrectly. Oh, so I think it's working because it is appending it. Oh wait, we're doing it twice. Delete this. Let me write if conditions not met. So like we don't need to like worry about destroying. Then we append asteroid. Because like if it is less than 0, so if it's like a negative, then we have to worry about like breaking it. Otherwise, we can just append it, I believe. Like for example, if it's like empty or it like doesn't fulfill this condition. Let me try and run that.
Nice.
Okay, it looks like it works for
Nice.
this. Let me just go through one more time. So 5, 10, 15. If it's negative 15, we go into this. Otherwise, we just append 5 and 10. Yeah, I'm pretty sure like while loops, like if it doesn't,
Yeah.
it like treats it as like an if, but
Yeah, I didn't know that on Python. Interesting.
can I try submitting it?
Yeah. Yeah, it works. It works. It's good.
Okay, cool.
Yeah. Cool.
Yeah, this should just be like constant for both. I mean, not constant, linear. Linear to like the amount of asteroids.
Okay, walk me through the time and space complexity.
Yeah, space, it should just be like if they like none of them are destroyed, it would just be like mx like the size of or like the number of asteroids, so it would be linear to like the length of the asteroids array. And then time, I believe it would just be the same thing because we're doing one pass.
Yeah. Okay, cool. All right, let's move on to. I think we got time for one more question.
Okay, sounds good.
You exit out of this.
Yeah.
I'm gonna send it to you.
Cool. Okay. Let me try this. Oh, I think I've done this problem before.
Oh, you've done this?
Yeah, I believe so.
Okay. Let's see. Yeah, don't really have any more questions. I think we could just probably end that there. You're just continuing to practice, right? So we could schedule another one. Because I can't really ask you any of the DFS or graph or tree one. So I think
I can try like the DFS maybe like it's like more BFS that I'm kind of stuck on, but like or like
Okay.
like a matrix question or something maybe.
Let's see. One sec. Let me grab the question.
That sounds good.
I don't want to give you too much. Don't want to give you a long question. All right. Okay, I'm gonna send you this next question. Oh shoot.
Okay.
Oh, I invited you to the same. Oh, okay. Okay, sounds good. Have you done this one?
I don't think so.
Okay.
Let me check.
Yeah, have a read at it and let's just work through it.
Okay, so given an integer array nums sorted in non-decreasing order.
Mm-hmm.
Okay, so it's sorted, and then we want to remove duplicates in place such that each unique element appears only once. And then the relative order should be kept the same, and then we just want to return the number of unique elements. Wait, so we want to modify it in place and then also return the number of unique elements. Okay. So consider the number unique elements in nums to be k, and we need to do the things following that are, we need to change the array so the first k elements contain the unique elements, and then the remaining are not important. Okay, so let's look at example 1, 1, 1, 2. We would output 2, so that's the number of unique, and then I guess like the last one like can be any number. And then for example 2, same thing, we just move the unique ones to the front, and then the rest do not matter. Okay. Okay. I think what you can do here, I think I remember like doing something maybe kind of similar like a while ago, but like I believe it's something where you use like you store the counts of like unique numbers or repeated numbers. I'm pretty sure it's like maybe it's like repeated numbers, and then since we know it's like sorted, as you get a number that is unique, you swap like positions until everything is like until you iterate through the whole array. So like all the unique ones are in the front, and then the rest should just be, it would just be like whatever you swapped it with. I don't remember exactly how to implement that. We can try.
Let's see. I'm not quite following what you're saying. Could you probably list it out?
I'm not sure if it's like a similar question, but like something where let's say you have like 1, 1, 1, 1, like 2, 3, or okay, let's shorten that actually. As you like iterate through, so let's say you see 1, right? You like keep it there since it's unique. So maybe we can like have a set or some shit, and then like when we see one that like is repeated, so it's already in there, we just like increment like a counter. Like let's say we see this, so counter would be 1, and as we see this, it would be like 2, and then when we see a new one, like a unique one, we just swap the value here with the index at like the current index minus like the amount of repeated ones. So we just swap 2 to like here maybe, and then when we get 3, it's another unique one, so count is still 2, and then we swap it to like here, etc., etc.
Wait. Okay. I mean,
always like maintain like that's where we're inserting like the new ones into.
So you have a count. So we have a pointer here. We have count
Right.
count equals starts at 0. Can you dry run me on that?
Yeah, we count starts at 0, and then like when we see one that like we've already seen before, we like don't do anything, but we like increment it to 1, and then when we see another one, we increment it to 2, and then when we see a unique one, so like 2 here, we just swap like the values at the current index and the current index minus like count. So
Okay.
-1, -2, 2 would be swapped here.
Okay, swap. So this becomes 1.
Or it doesn't need a swap, but like I don't think swap matters because we like don't use this. Like this is gonna be overwritten.
Yeah.
Since we have like basically count is gonna like I minus count would be the like index that we insert the next unique element at.
Okay.
Since we don't care about like everything following the first k, like I don't think we need to swap it. We just need to make the one that is like I minus count into it. And like when we see 3, since count doesn't increment, since we don't see a repeated one yet, we would just do the same thing. So I minus 2, so 3 would go here. And then let's say we have like another 3 and then 3 and like a 4. Count here would be 3, and then it would be 4. So we take 4 and then go 1, 2, 3, 4, and it'll be swapped to here. And then the rest would just be whatever.
Okay.
Let me try to do that.
Yeah, go ahead and try to implement that.
So for I in range len nums, let's have a counter. So count equals 0. To store, I mean, we could use a set, I guess. Let's scene equals set. And while, like, okay, if nums I not in scene, then we just do, so if it's not in scene, then we just continue. So let's do it. So if it's in scene, so like we've seen it before, we increment count plus equals 1. And then otherwise, we want to make it the index like I minus count. So we do nums I minus count equals nums I. Let me see if that works. So let's say we have like 1. Oh yeah, we have to add it to scene, but so we see 1, and then we just add it to scene, and then 2, same thing, 3, same thing. Oops. And then 3 again. Here we would just increment count again, increment count again. So count would be 3. And then 4, we would just take I minus 3, which is here, equals nums I, and then add it to scene. And then return, or no, we don't have to, we have to return 2.
Okay,
So return,
is this complaining about one thing? Oh yeah,
so is that?
okay. It's complaining. Okay, I guess it didn't look at their other ones. Well, I thought it wanted to swap, but yeah. So what's your time and space complexity here?
Space would just be like, I mean, worst case, it would just be like they're all the same. So it would just be, or I mean, they're all unique. So the max like size of the set would just be the length of nums, and then time it would just be, we're just doing one pass through, so linear as well.
Okay, so
The number of elements.
I'll ask you this. So it's an OVAN space, right?
Mm-hmm.
How could we get it down to OV1?
All right, we probably don't need a set. Since it's sorted, we could maybe do something like check if it's like greater. Let me see how we would do that. 1, 2, 3, 3. So we have 1 and 2, 3. So instead of like checking if it's unique, we can just check if it's like greater than the previous element. Let me see if that makes sense. So if nums I, so if I greater than 0 and nums I, oh no, this is checking if we've seen it. So if nums I, so if I greater than 0 and nums I equals nums I minus 1, that means, okay, so like repeated. Else, so if it's unique, I guess it's not like equal to the previous one. But in that case, yeah, wait, let me see if that works. And then we would just return something like length of nums minus count, maybe. So what this is doing is it's like checking if it's like repeated, because if it's like greater than 0, so like starting from the first one, if it's like equal to the previous element, then we know it's like a repeated. And then otherwise, if it's not repeated, we just swap. I mean, not swap, like overwrite.
Yeah, cool. Nice, yeah, worked. How do you think you did?
Like the whole
interview. Yeah.
like,
I asked you 3 questions. Yeah.
Mm-hmm. I think I did fine on like the first and this one, but the second one, I guess like I haven't been doing too many questions with stacks, so I would need to like refresh on that like a bit too.
Nice. Cool. All right, let me see my feedback. So yeah, first question, easy. You solved it easy. Good job. No real notes from that. I think it's all pretty easy. Q2, yeah. You let's look at question one actually. Question one, what you did well. You solved it pretty easy. I think you're good with the indices. People make mistakes on off by ones. Like maybe they access the end of the array. Sometimes like they just mess up the indices sometimes, but you didn't really run into that. In this question, people get wrong sometimes of like the conditions of when we're gonna keep looping and stuff. When you return true, they also get wrong that we need to try either deleting from the left or deleting from the right. But you caught that and cleaned it out. Have a clean solution. So overall, really good job. Second question, that's the one where you had more trouble with. I think the asteroid collision. I think for that, my notes about that is just I think dry running it on the comments and then reasoning about it. I think you just could just be a little bit more strategic in catching the edge cases. I think you knew exactly what to do, but all your if statements and stuff, you're churning a lot on it. Like you had ideas, but you're going in circles a bit, trying to figure out the conditions here. So I think you could be more strategic with how you like break down the different cases, and how you could be more strategic is work through the different cases or be more methodical. So what are the different cases for the asteroids, right? If it's
Right. Yeah.
equal, then what are you gonna do? If it's greater than, what's it gonna do, right?
Yeah.
If
I
it's
kind of
less
like
than,
that one I messed up because like I kind of had the idea of like what I wanted to do, but I should like planned it out like each case to like make sure I didn't like mess it up at any point. But
yeah. I think, and the best, maybe the a good way to do that is simulating it and just having the notes we had here. I think helped with your thought process a bit because you could see it there. Of okay, we're dealing with -5. Like when we wrote down the notes of what the stack is gonna look like and how we're comparing the last value to what's on the stack and how we're like moving it out. So I would just write some notes down so you could visualize it because you're good though because you're able to visualize it in your head. But if it was a more complicated question when you're visualizing in your head, you're gonna turn too much in the interview and you're gonna run out of time. So
yeah, definitely.
getting things off into the notepad to see, okay, run it to a case and write it down what case you're looking at specifically helps both you and the interviewer visualize it. So
Right, yeah, that definitely makes sense. Like even before you, I guess, like finalize your solution, just like having a separate section where you can like see how each part of like visualize what each part of your code does. Like that's definitely gonna like make things easier for like yourself too.
like I think
And
here, yeah, when we visualized it, you were seeing, oh, we just -4 and then you're swapping. I think imagine you just had to keep that in your head the whole time and there's a small logic error.
yeah, for sure.
That's like, yeah. But overall, really good. Ramp up on the trees and grass, and we'll test you there because those are the ones that are really you really get asked. You're really good though, honestly. For the questions I did, like pretty much no feedback. I think we solved 3 questions in 45 minutes. So yeah, we'll just keep up the training and just hit me up whenever you're gonna when you want to do more of the trees and grass. I think yeah, that's when we'll see where you're at because arrays, yeah, you're already good at. So I wouldn't be too worried about that.
Yeah, thank you. Sounds good. Yeah, I'll definitely like review those
Cool.
in the future.
All right. Thanks for coming out. Talk to you later.
Well, thank you so much.
See ya.
Bye bye.
No problem. Yo, chat, how do you think he did? Okay, I'm gonna get the next person on. I just need my water. Dude, every time I hop into Google Meets, it tweaks. Jay, what's up?
Hey,
How you doing?
hey James, congrats on 50K and congrats on Meta.
Thanks, man. I appreciate it. Thanks for hopping on again. I remember we did one way back.
Oh yeah,
Did we do
yeah,
it on
that was
stream? Like you
I
hopped
mean
on
I'm
stream?
still looking for a job. Yeah,
How long ago was that we hopped on stream?
like for January probably.
4th of January? That is crazy. Let's see. Yeah, that's a long time ago. All right, I'm gonna set you up. Let me take a quick break,
Sure.
and then let me just grab my water. I'll be literally 30 seconds. Just wait. Give me a sec. Jay, what's up? How you doing?
Hey.
Cool. Yeah. Just grabbing some water. You're my last interview of the day. Have you been tuned in,
Oh,
or
nice.
you just hopped it, or you just hopped in now?
What'd you say?
Have you been tuned in the whole time, or you just hopping in now?
I watched the last guy. He was pretty good actually.
Yeah, I
And
think he's good.
for I think he was a junior. I'm like 25 years old and I can barely do some of these leak codes. But I'm up to like 200 something questions now. But honestly, most of that has just been like going through the solutions. I'm
Hmm.
not sure how I would do in an actual interview.
Yeah. Okay. I mean, we're gonna put you to a test today, right? That's why you
All right.
scheduled the time, right? Just to see where you're at. Doesn't matter.
Yeah.
Yeah. What did I ask you last time? Did you do good last time? I don't remember.
I did okay last time. You gave me some palindrome string question, and then you gave me a tree question, which was the right side view of a tree.
I see. Okay. Cool. All right. I'm gonna start the video now and just give a quick background on yourself and how many leak code questions you solved. Maybe. Yeah.
Yeah,
Okay. I'm
sure.
gonna start this up.
Okay.
Hey everyone, so today I have my friend Jay on, and yeah, we're gonna do another coding interview. He's done one before, maybe 3 months back, so maybe I'll look back and see. We'll look back and see where he's at or how far he came. But yeah, Jay, you want to quickly introduce yourself? Maybe what school you went to, maybe
Yeah,
if
sure.
you work right now and companies you have interviews for and stuff, and then we'll get into like how many legal questions you solved.
Uh-huh. Uh-huh. So, actually, I'm a non-traditional CS background. My undergrad was in geography from U Chicago, but I'm getting my master's right now from UIUC in computer science. I'm a data engineer right now at this bio company, and I'm targeting basically anything right now. Um, I have Meta and Google coming up, but I would like to get something like Amazon just because they have an office in Phoenix and I
Nice.
really want to move out to the desert. I'm based in Chicago right now, so it's like the winters have been really rough on me. I'm at 200 leak code questions right now, or somewhere along those lines.
Damn, you want to live in the desert over the snow? So you're picking two extremes here.
Yeah, and I'll probably be moving in the summertime too. So literally going from like freezing to 120 degrees Fahrenheit.
Why don't you just move to California where the weather is mild in between?
Oh, yeah. I mean, if I can afford it, I'm open to all opportunities right now.
Okay, cool. So you did around 200 questions. What's the breakdown of those questions?
And keep in mind these questions are like over the past like years, but so I've done 40 easies, 170 mediums, and
Wow.
like 10 to 8, 10, yeah, 18 hards. But most of those are just like me looking at the solution and then I just submit it and not sure if I could get those again.
Okay. Let's go. How good are you at arrays?
Um, I would say I could do the hardest I could do is some modification of Kadane's max subarray.
Okay, so
Yeah, I could do like
like
a
out of 10, out of
subsequence.
10, give yourself a rating out of 10. How confident are
I'd
you in
say
arrays?
7.
7. Okay, Paul has one question. Are you doing those Meta and Google data roles, or that's software engineering interviews?
Uh, Google is software and Meta is data.
Cool. So arrays, it's 7. You're 7. Link list.
Linked list. I would say an 8.
Okay. Trees.
Trees, 6.
6.
6.
Okay. Graphs.
Graphs. Like 5 or a
5.
4. Yeah, 4.
Okay. Okay. All right. Okay. Cool. Let me look for a question. Just hop off the stream for now so you don't see what question I find, and I'm gonna invite you to the thing. Okay, let me look for a question. Let me think of some good questions. I'm gonna. Yep. Searching. All right. I'm gonna send you an invite to the first question.
Okay.
I'm gonna send it here.
Okay. Sum of left leaves. Is that the
Yep.
one?
Yep. Go ahead and just start. Yeah. Go
Okay.
through.
Given the root of a binary tree, return the sum of all left leaves. A leaf is a node with no children. A left leaf is a leaf that is the left child of another node. Okay, so in the example, the left leaves would be 9, yeah, 9 and 15. Uh, and yeah, and it just can't be the root. So 9 plus 15 equals 24. Okay, got it. So I would just traverse through this tree, and if I encounter a node that, well, if I need to know if it's a left leaf or a right leaf. So, okay. I traverse through this tree somehow, like maybe with a BFS or something,
Mm-hmm.
and I pick up. If I encounter a left leaf, I just add it to the sum. And let me think about how I'm going to determine if it's a left leaf. So it's a left leaf if, well, we have a node here, and then we have like node dot left, and then we have node dot right. So I take a look at node dot left. If node dot left has dot left and dot right, oh sorry, dot left, dot right are both none, then it's a left node. I don't want to go down to the left leaf itself because then I would have to keep track of if I came from the left side or the right side. So I'm going to only go down a level if I can verify that. I'm only going to go down to the left if I can verify that if that it has children. So like let's say that we encounter an example where we have like 4, and then we have like 5, and then we have like 6, and then we have like 7, and then 8, and then 9. So 8 and 9 in this case are going to be left leaves. So let me just make sure that my algorithm kind of takes care of those. So I would have some kind of like BFS queue or whatever. So in the queue, I would have 4, pop 4, go down to 5. Or sorry. Okay, so in the BFS, I have 4, pop 4. 4 doesn't have a right, but 4 does have a left. And the left also has a left, and the left also has a, yeah, the left also has a left, or it has a right. So I go down to it. So I do, or maybe not a BFS, a DFS is probably what I'm doing. 5, and then go down to 6, and then 6. I see that there's a node dot left, but there node dot left is none, and node dot left dot right is none. So it's a left leaf. So I add it to the result, and then I add, and then I do the same thing with 9 here. Right? Does that make sense?
Yeah. So you're checking if it's a left node up here,
That's right.
and you're checking if it's a left leaf here.
I'd never really go down to the left leaf. In my mind, it's easier if I like to keep track of if it's coming from the left or the right. Because if I go down to a right node, I don't want to accidentally pick up this this right node, this
Okay.
right leaf.
But how can we know at the right node if it's a left or right? Is there a way that we can notify it when we're visiting or when we're at that if it was a right or a left?
Well, I could. Well, if I just don't visit, the right node, and I only stay like a level above. That's kind of my original thinking. But let me think if there's a way that we can actually visit each node and not have this much nesting.
Yeah, it works, but we're doing like left dot left dot left dot left dot right. We're clicking in a
Yeah.
bit too much. That just looking for something a little bit cleaner.
Okay, gotcha. Let me think again. So dot right. Could I have a mm, could I have a left dot right. If the right node has with each recursive call, so like I could, if I do the recursive DFS approach, I could pass down a flag that tells it if I came at it from the left or the right side. So like node and then true false. And if it's true, so if true, I came from the right, or I came from the left, or something like that. That's kind of the only idea that's coming to me.
Yeah. So we're passing a flag. So from the parent, we're passing a flag down. So this one we're gonna pass down true, and this one we're pass down false because it's the right child kind of thing.
Yes, that's right. So like 9. So as we go down, so we start from 4, and then we go down to 5. 5 is true, but 7 is false. Since 5 is true, we're only going to, if 5 is true and we see that it has no children, then we add it to the results. But since it has children, we keep going down a level. So we pass down 6 true and then 8 true. 8 is true and it has no children, so we do add it to the results. By the time we get to 9 true, we also add 9. But since we're entering 10 with the false flag, we do not add it to the results.
Okay. What about right here? The root, is it true or false?
The root is false because it doesn't have it is not a child, so it is false.
Okay.
So we start off at false.
Okay, go ahead and implement that.
Okay. All right. Let's start with. Let's take care of. Okay, so let's start with the DFS function. Node is left. Right. So that's a Boolean. Okay. So if node dot. So first check if leaf. If not node dot left and not node dot right. Result plus equals node. Oh wait, if not node dot left and not node dot right and is left. Okay, so this is okay. If it is a child, then we do nothing. But if node dot left, DFS node dot left true. If node dot right, DFS node dot right false.
Sure.
Okay, let me think what else. Some edge cases. So if not root, or and if it's a singular node, let me see if singular node would be taking care of the edge case of singular node. Node dot right. Then we would just okay. If it's a singular node, it would just fail all 3 of these if statements and just do nothing. And then I'm just going to call DFS on the root false and then return results. And let me just do a dry. Does this make sense so far? I'm going to do a dry run.
Yeah, do a dry run.
Okay, so let's go through my example. Okay, so result equals 0. So far we have 0. If not root, return run, fails that. DFS on node is left. So I'm going to start with 4 comma true. Sorry, 4 comma false. So I check if it's a leaf, so not node.left. Fails that. If node.left, then I run DFS on 5 in true. And then I have to do DFS. No. There's no right child. So I just go down DFS 5 true. 5 is there is no dot left, fails this if statement, but there is a left child. So I'll do DFS 6 true.
Yeah.
And then I would do.
Let's just run the code now. I think, yeah.
Okay.
Sounds good. Just try running the code. Looks like there's an error.
Okay. Oh yeah. So. Okay. I'll just do this. I think that should take care of it.
Nice. Cool. All right,
Okay.
let's move on to this next question. Good job. Thank you.
All right, thank you.
Handled the recursion well there. Yeah, I think, yeah, definitely improved from last time. Oh. Okay. You just have to leave the last one.
Okay. Daily temperatures. Given an array of integers, temperatures, return an array and answer. Number of days I have to wait after the ith day to get a warmer temperature. Okay. Daily temperatures. So, yeah, so for each, so it seems like the challenge for this question is so for each given temperature, I just look forward in the array and just keep track of how many additional days it'll take for it to be warmer. But if the temperature is just going to go downhill from here on out, I just I give it 0 because it's not going to have any more warmer days. So so in this example, let's see. I don't have the skeleton code, but
Yeah, what the heck is going on? It's so weird. Usually this is the skeleton code.
Oh yeah. Okay. Okay, so okay. It's the code isn't color coded, but whatever.
This is so odd. Okay, wait. Oh, end it quick. Let's see. Okay, I'm gonna re-invite you. That was very
sure. I mean that's okay because these sometimes they don't give you the IDE. Like you have to code on a Google Doc.
Yeah, it's fine. All right, it's working for you now, right?
Yeah, it is.
Cool.
Okay, so working through the example of this temperature. So, well, what we could do is we could do the brute force solution where for each element of the array, we just keep we keep incrementing our second pointer until we see a higher temperature.
Sure.
And that would be like the O of n squared solution. And so it's probably going to be more efficient than that. I'm thinking maybe like some kind of stack would be helpful, but let me think about it for a little bit. If we have 73 and then we get to 74, 73 goes to 74. So are we adding to the stack if it's higher, or is it a decreasing stack? That's kind of what I'm stuck on. But I'll try what happens if it's decreasing. So if it's okay, so if it's 73, so we start off with 73 on the stack. Okay, and then we encounter 74. 74 is greater than 73, so we pop 73. So we pop 73, put 74 on top of it, and then I guess, and then we're gonna need to get a 1 from this. So we somehow produce a 1 from this logic. We encounter 75, pops 75. We compute 1. 71 is less than, 69 is less than, but 72 is greater than. So we popped 69.
Okay.
So we pop 69, we put a 1 here, and then since 72 is less than 79, we pop 79 and we put a 2 here, and or something like that. Yeah, am I warm or am I cold?
Just like, let me think about this. Like, let's just change this to like 69, 70. Right.
69, 70.
Okay. So, what would be the answer here?
The answer.
Just walk through this.
So first day, first day 73. We look ahead. There we are actually the greatest temperature. So it's a 0. 69.
Let's go here. 75.
75. Oh,
So, what was your approach? You're gonna add 73 to a stack.
yeah, 73 to the stack.
Then what?
Then 69 to the stack. Then 70 to the stack, but 70 is greater than 69, so I pop 69. So basically a decreasing stack was my initial thought, and then once we get to 75, we're able to pop 70 and 73. But I'm not sure how we get the numbers out of these. 1 1 because the answer for this would be 4 1 1 0. Maybe I could go the reverse side, or I could do like 2 pass throughs, or no.
So what's the problem here? You have one element here, right? You have one element, and you need to know when the next warmer day is, but you don't want to traverse there. Can't hear you. Oh, okay.
I could yeah, but well, I guess the one observation I'm making is that 75 is kind of the warmer day for 3 of these. So like I guess if I'm traversing there, it may be not as bad as I was thinking originally, because we could just have like a we could just have like a second pointer that looks ahead to the kind of a global maximum temperature, and then so we do like, so let's say this is J and this is I. We could just do like J minus I for each element. So J would be 3 minus I is 3. So we do like 3 here or something, and then we increment this. We increment I until we get to the point where they're equal. Okay, actually,
I think
maybe
you
this
mentioned
2
this.
pointers.
You mentioned this before, but like you're working from the front, but in order to work from the front, you have to kind of know. You have to look further up the array. Maybe explore working from the back.
Mm-hmm. Okay. So let's say that I and J just start at opposite ends.
Or
So we
just working
start
from the back the whole time.
or
Like
just
no I
working
and
from the
J,
back.
no 2 pointers, right?
Sure.
You mentioned
Okay.
working from the back. Like you could think of explore what happens. 75. What should that? Is 75? Is there ever going to be a warmer day?
No, 0. So we just like add a 0 here. Okay. And then we go back to 70, and we just, so like we have 1 here.
How do we know it's
We
one?
go back because I guess we could have like a running counter of consecutive days where the temperature decreases as we go backwards. Or no, we could have yeah, that's a good question. How do I know it's 1? We could have a because we have, I know this is 1 because it's less than, and then I go back 1, but it's greater than, so I have to know to make this equal to 2. 2, 69, 68, 75, 2. Yeah, if I could have a days till, like if I had like some kind of variable days till here, so I started off with 0, and then every time I go back and it's less than, so every time I go back and I see that 68 is less than 70, I add 1 to it, and then but like 69 I would have to and then I go back to 7.
Oh, sorry, I can't. You cut out, I think.
And then if I had like 76 at the beginning here, and then decrement this, so I reset to 76, and then I reset this to 0. But
I think the monotonic stack was also like the monotonic stack introducing that is a bit more warmer than where you're getting with right now.
Yeah. Okay. If I have a, all right, let's try the stack again, but working backwards.
Mm-hmm.
So 75, 75, 68, 68. Let's say that we keep 68 on our stack. 69. Well, we don't. Okay. Let's try a monotonically increasing stack. So, because 68, we're just going to skip 68 and put like a 1 here. And then 69, put like a 2 here. So every time we're unable to supersede the top of our stack, we just increment. So 73 would be a 3 because we've incremented 3 times and we still haven't beat the stack. But by the time we get to 76, we reset this to 0, and then we pop 75 and put 76.
Okay, 1 second. I'm getting confused here. So we're working backwards and we have a stack, right?
Mm-hmm.
So we're working backwards and we have a stack. Like you're saying it's like whatever, it's like it could be monotonic. Okay, and then we have some result. This is our result. Right.
Yes.
So 0, 0, 0, 0, 0. Right. Okay. So this is what we have. Okay, 75. What's the answer to 75?
0. The answer is 0.
Okay. And then what, do we add it to our stack or not? So,
Let's see. Yeah, I mean, I know the stack comes in, but I'm not sure what the stack should be describing. There.
so why would we need to keep track of 75 here?
Because we need to know that we need to know that 70. So to make sure that's for 68, 69, and 73, to be able to, because it's the warmer day for 73, 69, and 68.
Yeah. So
but
we
not
need to
for
know
76.
Yeah. That makes
So-
sense.
75, right?
Okay.
68, 68, no. 69, no. 73, no.
Or what do you mean 68 no, 69 no?
68,
Like, as
don't
we're-
add it to the stack.
As we're moving the integer, right, we should be updating the result. So 68 here. When's the next day that's hotter?
75 for
Okay.
68. So we add it to 1. Or if it's a monotonically decreasing stack, we could try we could try adding it to the stack, and then when we get to 69, we pop 68 and put 69 on here. And then that will be that'll allow us wait. Okay. If it so 68, so we change this to 1. Now we're at 69. We see 68 and 75 on the stack. Then we increase it to 2, but I'm
Why
not
would we
seeing a
say
2 here. 2 because the length.
It's like what a monotonic. Okay, we're gonna add 69 into the stack, right?
Yes.
So if we need to add it to the stack, can we just add 69? Okay, you already popped out 68, right?
Yeah.
Already
Well,
popped
yeah, I
out-
popped
okay.
off 68.
Okay, it makes it monotonic. Okay, Basically,
If I have to pop it, I
do we know the
increase it.
difference between these two dates then, like by indices? Like we popped all of the ones in between, right? So like if we kept track of the
Mm,
index, can we figure out the distance between them?
yeah, so we could do like 75.4, and then we would see 69.2. Mm, and then, well, we go from 68.3. $75.4. Okay. Well, we first of all we pop this, and then the top of the stack will be 4 in comparison to the 2 that our index is currently. So we know that the answer is 2 for this one.
Okay.
But then after we're done, we add it to like 69 comma 2, right? And then when we go to, like, for example, let's say that we change this here. We add like a 68 again, right? So 68, we see that our top of the stack is 69.2, or I guess, okay, I just inserted our example. So sorry, let me just change the indices. So once we get to 68, we see that the top of our stack is 69.3. Well, 3 is just 1 greater than 2, and we're currently at 2 right now. So we change this to a 1,
Yeah.
and then we pop. Do we pop it? No, we go like, we go 68, 2, and then 73. 73, we have to pop. We have to pop all of these until we get back down to 75.
Yeah.
And we see 5. Well, I'm 1 right now, and the next one is the top of the stack is 5, so I put a 4 here. And then when we get to 76, well, our first job is to pop everything from the stack that is not, and we see that the stack is empty, so this stays 0.
Okay. All right. Go ahead and
Okay.
implement that real quick. I have to
Yeah.
hop in a couple minutes, so.
Okay. So, and we're going to go. So I'm gonna have a for loop here, have a stack here. Our stack is so. First, pop everything from the stack less than me, and then second, compare my current index to the top of the stack, and then add myself to the stack. So I am currently current temperature is equal to, so while stack and stack -1, and then so the stack is going to have tuples temp index tuple, so and stack of 0 is less than cur temp stack.pop. Okay. If stack and if stack, okay, well, if there is no stack, answer is equal to 0. Else, answer is equal to stack -1 1 minus I. Yeah. And then, okay, I'll have my result array now. So like that's 0 times length of temperatures. So res of I is equal to answer. And then stack dot append cur temp I. Okay, so dry run. My example here. So res is 0 times length of temperature. So I have I here, right? I start from the end here, 75. Current temperature is 75. There is no stack. So the answer is 0. The answer is 0. So res result of I is equal to answer 0. And then I add myself to the stack. So 75, 0, 1, 2, 3, 4, 5. Okay, yeah.
Cool. Let's submit the code. Wrong answer. You debug that
Okay.
case?
Yeah, let's take a look at it. Wrong answer. Okay. Well, so this is the wrong answer. All right, let me think. So I start, so 70. So 70, that's 0. 100, that's 0. 76, that's 1. 46, that is well, on the stack I have 70. Yeah, 46, that is 147. Oh, yeah, I forgot about if they're equal to each other. So I need to add an equal sign here. I can try again. Okay.
Nice. Cool. How do you think you did?
Bad. Well, I mean, I did eventually get it, but you had to give me like basically all the hints. So, yeah. It's just like if it's really difficult under pressure if you've never seen it before.
Yeah.
To like talk through it.
Yeah. Honestly, you did pretty good, pretty better than the last one. I think, yeah. Probably with the second question, I gave you too many hints. But you did show good coding skills, being able to code it up as soon as pretty fast with no bugs. And understand, like, you knew the monotonic the monotonic stack. You knew, you kind of thought maybe we can work from the back. So I think the more thing with you is iterating through the different solutions and trying to figure out what way is going to work. I think your coding has improved a lot from the last one. Your dry run was really good because you're able to catch your error. And yeah, you got it working. So I would say, yeah, like the main thing, I just had to give you too many hints. I don't know if I'd be able to pass you if I gave that many hints in an interview. But it's not like you didn't know the concepts that I gave hints on. It's more of that you just didn't explore that path. So yeah, like you're like, okay, let me just move from the front. So a lot of with these array questions, right? If you can't solve it moving from the front intuitively, try looking at it going from the back. There's pretty much only two ways that you can go through arrays: moving from left to right or right to left. Or yeah, even two pointers. Like, but I think a lot of candidates sometimes they forget that they can go backwards from it, and yeah, I think going backwards here was a trick, and yeah, I think
Mhm,
now you'll
mhm.
never forget to look backwards through an array. But
Yeah,
otherwise, you're
yeah.
good.
Well, I learned a lot, and I appreciate the practice.
Cool. All right. Thanks, Jay. Let me know how your interviews go. I'll message you again. If we could probably slot in another one. I really want to make sure you're prepared for those interviews. So I'll
Nice. Yeah,
schedule
I
it.
appreciate it. Hopefully, I get good RNG and they give me an easier question. But yeah.
Cool. All right. Catch you in the next one.
All right.
All right. See you. Bye. Damn, 1,600 questions. You're wildin', man. You're wildin'. Yeah, you could probably pretty much do every single question in the book. What's left? All right. Thanks everyone for hopping on the stream. Nearly 4 hour stream. Kind of crazy. I think everyone did pretty good. I think people have been watching the videos and understanding how to do coding interviews. Honestly, a lot of the people that hop in. Ezra, are you part of our Discord? You should hop in our Discord. We run these all the time. I run it with people who've done as many questions as you too. I've done 650, so we could run it on each other. Yeah, we run questions. I had a Code Forces Grandmaster hop on at the very start of the stream. So we have people coming in from beginner all the way to Grandmasters at Code Forces. So hop on the Discord. We're gonna get the Grandmaster guys again. I know other people who are really good at lead code too. So yeah. I actually was able to get him with the question. I actually got him with a question that he couldn't figure out completely. I had to give a small hint. So I was pretty happy about that. But then I gave him a hard he was just warming up. I gave him a hard question, he just bodied it. But Ezra, join the Discord. I asked him. Let's see. Let me bring it up. So this is the Code Forces Grandmaster guy. Plasmatic. This was earlier today. So I asked him insert delete get random. So I asked him this question. And he was able to solve with a small hint. And he was able to solve rotten oranges in like 5 minutes. That's classic BFS. And then this dice roll simulation one. This one he solved really fast too. Like you could see that I literally popped it up right here. What is it? 36 minutes in? And then by 40 minutes, within 4 minutes he's typing the code. And then it's just like passed already right away. So this guy was a beast. That was like have you solved this question? It's like a 2000 elo question on Zero Track. Yeah. I'm gonna ask him even harder questions than that. But Ezra, I hope to see you around. Where are you working right now? How come you do leak code? Do you already work in the industry, or you're just doing these for fun? Oh wow, you're not even in CS and you can solve them? You're crazy. All right. Ezra, nice to meet you. Alex, good luck on all your meta interviews. 7, you're about to start college. Sick. Senior software engineer does Code Forces. Yeah, maybe I'll try to get to Code Masters, Code Forces. But all right. Thanks everyone for hopping on the stream. Actually, I'll be on tomorrow. Paul's gonna be in the coding interview. Alpha is gonna be in the coding interview, and I have a couple more people. Hop on tomorrow, same time, 12 Pacific time to like 4 Pacific time. It's kind of the schedule. But all right, see y'all in the next video. It's one of my friend's birthday, so I'm about to hit the club. All right, catch you. Peace.